I think he speaks to both the engineers and like the managers and kind of people of all different backgrounds.
Wasn't it the last year at GTC when he was he had like a virtual AI generated kind of avatar thing when he made a presentation?
Yeah. So for I think 2 minutes they completely generated him, where like everything was CGI essentially. Now in the latest one, they have this like virtual Jensen all the time. That is like computer generated. His voice is also generated on the fly. That sounds like him, and also the sort of what he speaks. Virtual Jensen is also generated by one of like the large language models that they train from like Megatron. So basically everything from this.
Can you ask questions to Virtual Jensen and have it reply?
I think so, at least internally. Yeah, I think that's coming externally as well. And they're expecting. There was a demo on GTC where they're expecting virtual avatars to join meetings as well in order to act on certain requests and look things up and stuff like that. So it's in some cases it feels like they're creating the world in front of you, which is definitely a big change from coming to from Spotify, where it's a music app and a podcast app, but it's not the same.
Imagine, I mean, that is the proper type of chatbot that you would like to have. Like if you have a properly, a natural language and I guess speech generated, responses in real time, right?
That's kind of they talk like they describe it as your digital twin, which is interesting. Which goes about like avatars, but they're also doing like sort of digital twins of virtuals or like real spaces. So they work with like BMW and Amazon to basically completely generate or like have a virtual version of their warehouses and their factories.
Is that the thing that they call Omniverse?
That is Omniverse, yeah. So it's basically like a physics-enabled like computer vision systems, similar to like where you can kind of generate like virtual worlds. Yeah,
I added this as a topic because I think that would be interesting to hear more about, and also thinking about Facebook's metaverse and whatnot, and how this can play out.
Everyone all of a sudden started moving into the metaverse. Like it's a hot topic, but NVIDIA is in an interesting place, of course, there because they have like for 20 years experience with computer graphics and kind of being a gaming company. So they don't have to make an aggressive move like Microsoft had to do with buying Activision. Yeah.
But also in GTC now, that was it 2 weeks ago? Or
I think 2 or 3 weeks ago, yeah.
And it was a new release as well of Merlin, right?
Yeah, so actually it was our Merlin 1.0 release. So we...
how long has Merlin been around, by the way?
I think the team has been around for like 2 years. It started, I think, with my manager as like an individual contributor with one other engineer, and now he became the manager and like started hiring. So we have people that worked on Amazon before, Spotify. And it started kind of with... What are the biggest bottlenecks when it comes to training machine learning models for recommender systems, especially on the GPU? And kind of the two areas that they identified was data transformations. So typically, if you have tabular data that you need to transform that in order to give that to a machine learning model. So you need to do things like if you have continuous features, so like real numbers, like the number of times that like a user logged in, for instance. You need to all scale that in the same range. Otherwise, like these algorithms won't be able to train. And for categorical features, so these are things like genres.
Don't go too technical now. I think we have a separate topic when we go into what Merlin really is and stuff like that. But
I'll keep it high level. So basically, those common transformations. You're able now to do on the GPU, so it's more like a 10x speed improvement, which was always like a bottleneck before. And the second thing was that the data loader, so when you train a model, sort of getting the data from disk into the model was a major bottleneck as well. In a lot of cases, because that was so slow, like the GPU were underutilized. So with the standard data loaders that you had, and like TensorFlow and PyTorch, kind of the machine learning frameworks that people are using these days, like that was the biggest bottleneck. So like when we fixed that, all of a sudden, like because like computer vision, like and natural language, like when they started using specialized hardware like GPUs, they saw like at least like a 10x or 20x speed improvement. But that wasn't the case for tabular data and recommender systems. And then with these data loaders, they actually could get there.
Is that one of the biggest highlights, or what are the biggest highlights for Merlin 1.0?
So there's two things that I just described were part of NV Tabular, and that was kind of like the first library that they had, and was the only library that they had when I joined. Now at Merlin 1.0, we released the first version of Merlin models, so a machine learning modeling library that works with like both the two major machine learning frameworks out there, so TensorFlow and PyTorch. PyTorch is still in the making, but the TensorFlow is getting there.
So which one is the furthest ahead, so to speak? Is it TensorFlow or PyTorch?
TensorFlow is the furthest ahead because most of our customers are actually using TensorFlow because it was around there earlier and like for production use cases. It's been like kind of the leading contender for a while. It's slowly changing though, so we do expect more and more companies to move to PyTorch, but for recommender systems use cases, it's been mostly TensorFlow.
Cool. Well, I'm looking forward to hearing more what NV tabular and Merlin models are.
Yes.
But how does it work when you release like 1.0 in a big conference like GTC? Do you have a big show or someone presenting something, or how does it work?
It was mentioned in like the keynote from Jensen, and then we had a talk from our manager that presented like where we were, and then we had like a 2-hour tutorial where we basically went in depth around Merlin models in a more interactive fashion, where people there were taking part of it. We would give them like a virtual node with like a GPU. They can actually run some notebooks and train some models. So yeah, that was kind of it. But like in the keynote, it's always a bit challenging because like it's typically 1.5 hours long, and like they're doing so many different things at the same time. And for a lot of other use cases, let's say like self-driving cars, it's much easier to come up with like a nice demo because they just show a car that's driving itself or parking itself. When it comes to recommender systems, like we don't have flashy demos like that. So that is one of the things that we always struggle with. Like we can, for people that are doing it, we can kind of convey them what we're doing and why it's interesting. But for the general public, it's always a bit challenging. Where basically what the only thing we could do is giving numbers like how recommender systems are used in the major platforms and how it's shaping the internet, and then we can solve that for you with this tool chain. That's kind of what we can do.
Sometimes annoying when the cool technical or mathematical solutions are not as sexy, like visualized, or you don't have as an attractive way to visualize it and speak about it, right?
Exactly, yeah. And then it's like extra challenging because NVIDIA doesn't have too many use cases for recommender systems internally. Like for instance, Spotify, like everyone could play around with systems like Discover Weekly, and then they could kind of get a sense of what these algorithms were doing. But we're basically providing the infrastructure and the tooling for companies to do that. But we don't have access to the data, which makes it even harder to come up with a good demo. And like, there are not that many like industrial scale open source data sets out there that we can use for this. And even like there are a few more coming, so it's getting better. But even with those data sets that are out there, it's hard to make it interactive. It's not that we can sort of give you as a user or like someone that looks at the presentation a sense of like, okay, this is what the algorithm does, because it's trained on like
I remember, we had a fun thing in a hack week in Spotify at one point. I'm not sure if you were there at that point, but we had Bartendro. It was a robot bartender.
Oh, interesting.
And then we basically built a recommender system for connecting the music taste that you have with what drink you like. So we had a user item matrix thing, or annotating some data, what kind of drinks you like, and then you connect it to the Spotify profile that you have. And then you try to predict, what kind of drink you should have. It was a really fun thing. I mean, you should have that as an NVIDIA kind of showcase, perhaps, for recommender systems.
We're always looking for new things. Like, we were definitely, like, right now we're basically building, like, the first platform, so our tools were not really up to the task. But now for next year, we want to do more, actually, customer engagement and actually get some usage of some of our tooling. Like, NV Tabular is used, like, a reasonable amount, but, like, Merlin Models is completely new. We have Merlin Systems, which is more on, like, the serving side. Also, it's, like, the 1.0 release, so we have no external use cases of it yet. So it would be interesting if we all get it to a point where we can actually start doing these kind of things and make the demos more interactive as well, because there's a lot you can do with data on the internet, of course.
Right. And just to close off GTC a bit, and what does GTC stand for again? The conference name?
Okay, now I'm going to feel hard because
have to Google that. Perhaps.
Luckily, they didn't let me do like an NVIDIA start exam, because I guess it's like the.
No, I remember I went to GPU Technology Conference, of course.
I should have been able to guess that, actually. Yeah, that makes sense.
I think I went to the GTC in 2018 or something, and I think they had the first release of the GTX machine at that point.
Oh, right,
the one,
yes.
GTX 1,
yes.
and they had one, and I could go up and I could touch it. Like I could put my hand on the machine, and I took a picture of like this is the first time, you have a DGX machine.
And those are nice looking machines as well. Like it's fun to see in real life. That's harder now, of course, as well. Like the last few, because it's twice a year, the last few conferences have been fully remote. We had some hope that this one would be the first one in a while, be in person. Yeah. But then COVID scaled up again. So now our hope is that in the fall we could actually do it in person again, because that would be great. It would be a good opportunity for me as well to meet some people.
I had actually a big disappointment with GGX, and that was actually had a DGX machine delivered to this place, the data club here, that we record the podcast. And I was like, oh shit, we have to do a cool demo, because we had like recording here, live stream and whatnot. And I was thinking, we have to do something cool, demonstrating how fast it is, and etc. So I was actually preparing that quite a lot. And then it came here, and it was like a dummy machine. It was like a DGX machine that had some kind of manufacturing errors. It was just like for shows. It didn't really run.
I didn't even know they existed.
Yeah, so I was so disappointed.
It was so heavy. It was around 150 kilos, so we needed like 10 people to bring it in, and then it made the hole in the floor upstairs.
Oh, it did.
Yeah, so it was. So we put it basically on some kind of a stand. But it is impressively a good-looking machine.
Hey, it is. So they're even sending out like the one with faults because people want to showcase it.
Exactly, just for demonstration purposes, and then it didn't run. But
that's a disappointment.
So the next one, actually, NVIDIA sends to us. We have a one that actually works.
Yes. NVIDIA, please send one to Hyper Data Club.
What's the
They can send me one as well if they want to. But
exactly.
I have like a beefy machine with two good GPUs, but no DGX machine, unfortunately.
A100s or H100?
No, so the A100s, they didn't send it because they need special cooling and they don't work for graphics. So it's just like A6000 or something. And they're good though. It's like 40 gigabytes of memory each. Like it's, I can't work without them anymore. Like you start to get used to it pretty fast.
For gaming or AI purposes?
Mostly AI purposes, work purposes. I haven't started using it for gaming yet, but maybe one day.
Yeah, only 150K for just, is it A100? No, it's a GGX,
Yeah, I think they have like a rental agreement as well. I've seen some people that like rented it for a while.
Yeah. Only $9,000 per month. Sounds good. Okay, cool.
We can still rent it for 2 months. I think I have like sold it for 2 months.
Should have it at the upcoming Data Innovation Summit, as a showcase. I think a lot of people will be really interested in seeing that thing. Okay, I'm trying to close off the GTC topic, but it's so many interesting stuff there. I didn't see the keynote. Do you remember any other highlights? I know the H100 chip was one of the highlights, right?
Yes. Yeah, exactly. So it's a new like top tier GPU.
So that's a successor of A100?
Exactly, right? Yes. Which I guess it's again like a 10x improvement in many ways.
It said I think 3 to 5, but I'm not sure.
It depends on like the use case. I was reading a little bit on about today, but it's wild. And then I think then they have like the DGX machines. So there's 8 of those.
With H100s in them?
I think so as well, yeah. And now they also release, because then they have like this NV-Link, so the GPUs have GPU to GPU communication, which is ultra fast. And now they also release like the NV-Link, I think it's like a routing box. I'm not sure what like the name for it is, but it's basically you can just link DGX machines as well, and you can just scale out more and more.
Yeah, between DGX machines.
Exactly,
right?
yes,
Yeah, we have the big cluster in Sweden, in Linköping, called Berzelius. It has like 60 GTX machines in it.
Oh, really?
Yeah, so it's one of the bigger ones in Sweden, at least.
Nice.
With A100s in it, but
it's still blazingly fast. So what kind of company is it? Can companies use that, or is it more for governmental?
You open a what do you say, a bag of worms here? But we can speak about that. I actually add that as a topic. I think that's interesting. How do you make these kind of data clusters useful? Because it's funded by partly Wallenberg. Mm-hmm. But then they want to open it up for certain purposes, partly, of course, research, but also for some potential commercial purposes.
Right.
But to do that, it's not an easy thing. But so I'll get back to that later.
Interesting. Yeah, it's hard to nail that from like a policy perspective.
Yeah. But training like big Swedish language models is one of the use cases, of course.
Right. That makes sense. I guess that doesn't always get prioritized by the big tech companies out there.
Yeah, exactly. Okay, cool. So the main highlights was basically the H100, GDX machines, anything else you remember?
I think they had like a new version of Omniverse Cloud, so it makes it easier for designers that are designing these virtual worlds to collaborate.
Yeah.
Which was interesting. It's hard because they basically just release stuff like for like 1.5 hours they talk about it, so it's a lot of information, but they're kind of moving on all cylinders.
Yeah. I'm trying to just Google up a couple of highlights here. Top 5 announcements and see what it is here. It's a bit slow.
Yeah, what is interesting to me is that these GPUs are like utilized more and more for various use cases. Like it started with gaming, of course, and then it was like machine learning modeling training, but now it's also data pre-processing, and they have specialized things for genomics, and then what I work on, the recommender systems. So they're using it across the stack, kind of like we're kind of moving towards like a platform where, like, if you have an end-to-end pipeline that like transforms some data, trains a model, and evaluate it, instead of only doing the model training on the GPU, you can do all of it on the GPU, which really means that like your end-to-end pipeline starts to go like.
I think that's a really interesting point, especially in recommender systems. That's important, I guess. So it says something about million X computing. I remember I heard something about it. But AI is basically, it's not the normal kind of Moore's law, like doubling every 18 months. It's actually million X performance on some of the tasks that you can do if you're using deep learning properly.
It's wild. I mean, like, since it's sort of parallel computing at its core with these large matrix vectors, or like these large matrix multiplication operators, so then like you have more leadway as well in order to get like more than Moore's law, of course, because the algorithms are sort of optimized for just making them faster by just getting more cores
just
in them.
Converting them into a GPU as
exactly.
It makes it super big. Other stuff was like the transformer-based, ships. I guess that's H100s that have special, transformer support.
Right. The transformer is kind of taking over machine learning, so they're doing more and more to optimize these things.
Yeah.
And they're working on this library called Megatron as well to make it easier for companies and customers to train these really large models. I think the biggest that NVIDIA has till today is like 540 billion parameters out of my head, which is wild. It's like that these models become this big. And it has a lot of implications. We can talk about that. But that is,
I have it at this topic, the scaling of AI models, etc., in the future. But also some other things was data centers turning into AI factories, and I guess it's the connection between GGX machines and stuff that you mentioned.
Yeah, they're seeing themselves more and more as a data center company. So not just individual GPUs, but just like lining them up and just making sure that these things can be used in end-to-end, like real use cases.
Yeah. And increasing demand for robotics system. I think it's been lagging for a long time, but glad to see that some stuff is happening there. And then also the thing with Omniverse that you mentioned, the digital twins for next generation AI stuff. Yeah,
and they're expecting like a lot of implication for robotics there as well. Like if you can simulate more things out there and it's more realistic, because often like getting training data for these robotic systems is super like costly. So the more you can actually simulate and then take it back in the real world, is that makes it super powerful. And that's why Omniverse is very interesting, because it has sort of physics baked in. So therefore, like it's super easy to create these virtual worlds that kind of behave in a similar way as like the real world.
It must be a perfect sweet spot for NVIDIA that had like a background in gaming and rendering and graphics, and now also in AI, and combining the two into building like a digital twin or an Omniverse. It seems like a perfect fit in some ways.
Yes, and especially if you look at Jensen's background, like it's perfect. Like how the world, like where it's going, like it's perfect for the company. They could have never envisioned it 20 years ago when they started it, but a lot of elements where they happen to be working on, it all comes together. But they made some impressive bets as well, like very early on. When deep learning started to work, like they really kind of pivoted and like invested huge sums of money, and were one of the few. Like if you look at Intel and a few others, like they weren't as aggressive, and it definitely paid off in the long run. But sure. I mean, it's still a tough competition out there. So it's like they have like a strong lead now, but there are no guarantees that you can keep that up in the future, of course.
Yeah, looking into the future is an interesting topic. So let's speak about that shortly. But Marc Romeyn, very welcome to the podcast.
Thank you.
I think we've known each other for 6 years or something, right? Or when was it you did the intern thing?
You hired me at Spotify as a summer intern when I was
15?
I'm 30 now. I think it was when I was 24, 25, so maybe 5-6 years ago, maybe 7.
I remember I had a very difficult thing for you as a project, but you actually managed to do that, which was very surprising to me. But I think we should actually move into that shortly.
Yes.
The deep retention, if I remember correctly, right?
Exactly, yes.
Because it's connected also to recommender systems, right?
Yes, yeah.
And I think that's very, nicely plays into what you work with today as well. And also, I mean, you're an awesome person in many ways, not only like technically, but you've also been, a winner of multiple awards, and you had the EIT summer school thing, right?
Yes, yeah, that was my studies, the masters that I did.
And hackathons that you won, and
few hackathons. Yeah, I've always been quite competitive. When there's a competition element, I like that. I played a lot of sports when I was in high school, so I always had that in me.
Yeah, and it's really impressive. So it's a true pleasure to have you here.
Thank you so much.
And perhaps you should start. Simply, who is Marc Romeyn? How would you describe yourself? What's your background?
Yeah, so my name is Marc. I'm 30 years old now. I'm currently living here in Sweden again. I think this is like the third time I'm living here. So I grew up in the Netherlands, did my bachelor's in what's then called knowledge engineering, so basically like artificial intelligence. Took me 5 years to finish. I had different priorities at that time. I was 17 when I started, so I wasn't the most serious student out there. And then in the beginning, I was kind of thinking that. So my dad has a background in machine learning, so that's kind of like how I ended up there. Otherwise, I don't think I would ever have found these studies. And I started building websites when I was like 16 or something. So one of the competitions that we won in high school was basically for, like, in the Netherlands, you write like a final paper before you graduate. Right. I think it's like 20 or 30% of your grade or something.
Similar to Sweden.
Yeah, and we built this website. So in high school, we had this graphical calculator, like the Texas Instrument.
Yeah.
TI-85? Yeah, 84 or something like that. Yeah. And
I had the HP 48. Hewlett Packard had a similar one. It was these two that were competing, I think, the TI-85.
I think in the Netherlands, everyone had the Texas Instruments, so maybe they had some sort of monopoly, or maybe we had to like buy that one. I don't know, some sketchy deal. Yeah. But you can basically program in BASIC on these. And then I think like the first time our physics teacher like explained us like how to write one of those programs for one of the formulas we were taught. And then we're like, all right, this makes life much easier. So we started implementing those for a lot of them, and then we built a website on it where basically people could download their own and upload their own versions of it, because every time we had a test, people always come to us and you had this like little USB cable that you can sort of transfer programs from one to the other. They always wanted like the ones that we had. So that's kind of like how it started in programming. And then I worked for like a design agency for like a summer when I was like 16 or 17. So then I got like Photoshop, like a layout of a website, and then I had to turn it into CSS and HTML, which was interesting. And then I started like studying knowledge engineering, thinking that it would be more engineering. I actually thought it would be sort of like more cognitive psychology as well, where like we would study the brain more and then kind of try to apply it. It was kind of my version that I created in my head. As you hear, I didn't research it all too properly, I guess. I just followed my dad's path. And I struggled with like the large amount of math that was in there, and I didn't really see it leaning to anywhere. It was also pre-deep learning, so all the machine learning methods that we were learning were not working at all. So at some point I was like, okay, I just want to go back to, or I just kind of want to focus more on real engineering, because I always worked on the side, like 12 hours a week as an engineer at like a company in Maastricht. So then my master's was more like general computer science, because I saw like when I was working part-time that like the thing that was holding me back the most was actually the engineering skills and sort of learning more about computers. I never really understood like how network calls were being made. Like we're not going to get too technical. There was a lot out there that I didn't know, and I kind of was self-taught in that front. So then I think after 4 years I only had like 80 credits out of the 180, so I was definitely not doing well. And I was also telling my parents that I was going better than next went, so then I had to come clean. I was like, okay, now I get my stuff together. So in a year I finished it and sort of realized that I needed to get out of the city and I really wanted to go abroad. So then I started doing these studies where I studied 1 year in Berlin, and then the second year was at KTH here in Stockholm. And
that was the EIT double exam thing.
Exactly.
Right.
So it was my specialization was cloud computing. So that was like 75%. So distributed systems. Like in Berlin, we had a bunch of classes from people that were behind Apache Flink, if you know that.
Oh, I know the founders of it. I mean, they are awesome people.
Yeah, so that was amazing. So that really got me like the proper computer science like experience, and I really liked it. And then we got some like entrepreneurship courses on the side. And then when I moved here, like that was kind of in the summer, I started realizing, oh, actually, my machine learning knowledge could be useful because deep learning just started like working essentially.
Right.
When I started to read up on it more, it was essentially, well, we can scale up these algorithms now because we learned a little bit more about the algorithms, but there was a large part was also we can just build better and larger like distributed systems, which is essentially what I was learning in my master's. Like, okay, this is actually the sweet spot. So then I really prioritized trying to write my thesis around like some deep learning or machine learning subject to get back to speed. And here at KDH, I took a few machine learning courses. I realized again that the math was tough, but I'm happy I did it. So then I wrote my thesis here in Stockholm at a company called Doer.
Yes.
So it's like an accountancy company from like a serial entrepreneur that already like sold a few of his earlier companies for a lot of money. So it was a very different experience. It's like joining a startup like that had already kind of
How
like
big
unlimited
were
amount of
they
funding.
at that time?
I think when we joined, so it was me and Jan, like one of my best Dutch friends that I was studying with. We both joined as like machine learning interns to write our thesis.
Yeah.
And the idea was essentially that we would use deep learning to extract information from receipts.
Right.
Because people were sending them receipts and they wanted to kind of extract what the total amount was, where was it received, and stuff like that.
I know, the company that I worked for before was Algotorial, and they actually worked with Doer as well.
Interesting.
Yeah.
So we had like, so my supervisor was Roelof, was like a Dutch guy, was quite active here in like the machine learning space.
Yes.
And he was working for them at the time. And then we asked him, okay, could you be our supervisor? And then we write our thesis there, and we set it all up. By the time we started, Roelof was already gone. So then we were kind of on our own, and like they didn't really want to give us access to the data all that much. We still wanted to sort of write something that could potentially be useful when they gave us the data or when they decided to use the algorithms. So then we found this data set of kind of annotated scientific papers where the data set consists of like the PDF, so we could extract the text, but they were also completely annotated where for each word it had the bounding boxes, essentially, like where was it located on the page.
Nice.
So then our task became, could we extract based on the word and kind of the place where it is placed on the paper, what part of the paper it consists of, so like the title, the authors, the abstract and stuff like that. And then we were two of us. So then Jan kind of took the computer vision approach where you just convert the PDF into an image and then you try to basically get bounding boxes around, okay, this is the title, this is the abstract and stuff like that. And mine was more on the NLP side of things where we used the text and the location, and then I wrote like a recurrent neural network, an LSTM, to then word by word predict what part it was what part of the paper was part of. And then the idea was that then afterwards they could combine it, so then like computer vision with NLP, and then hopefully it would increase the accuracy. We never really got there, but it was a very fun project. And then that was also the first time actually we got to work with GPUs. They gave us a box in our office, so it felt very real time. Every time we deployed a new model and we trained it, we could hear this machine going off in the background and making a lot of noise. So it was a very fun experience to be there, and it was very good that we were two of us as well, because we got very little help from the company.
It's surprisingly hard to just do OCR, optical character recognition, if you have this more structure into it with tables and whatnot. Right. I think there was a Google paper recently.
Yes, I saw that. Me and Jan sent it to each other. Like, okay, actually, it's now starting to be solved. But
do you remember what it was called? The paper?
I can't remember the paper anymore, but I think.
But it was some really impressive thing.
Exactly, and it was also on structured documents, actually. It had a similar idea where, like, just also on the location, you can infer a lot of things. I think it was also for, like, magazines. And I think receipts was also one of, like, the issues, like, one of the things they looked at. But it was also a time where, like, machine learning just started working. I remember, like, while we were interns there, it was when DeepMind had like that whole event where they won against like the world champion in Go. So it felt like quite inspiring for us as well to sort of like be in like the middle of that, where we just started learning about it. And I think it was like the first version of TensorFlow came out while we were interns there, and then we started like working with TensorFlow, working with Keras. So it was an interesting time where we basically just got like a a fast course where we can just try things out, and we had good hardware. And that led to like the summer internship at Spotify where...
How did that happen, by the way? I don't remember exactly.
It was a weird process at the time where you could apply for different verticals. So you had like design and then back end, front end, and then machine learning, I think was one of them as well. Yeah. And then I think the majority of the process was actually CV based. So I had to send my CV. And then at some point, the recruiter told me you were like the last 25, and then I think then it went to the teams, and then they cut it down to like 5. Yeah. I think in the end they had like one interview for like 30 or 40 minutes with Boxen, very nice guy.
Boxen at that,
and he got like kicked out of his meeting room in the middle of like the interview, and then just like started like still talking to me, trying to like walk through the office in order to find like a new room. And then the day later, like they told me that like I could start, which is surprising me because I thought there would be many more interviews. And then at the same time, actually, I also was in the process for this startup accelerator called Entrepreneur First.
Right.
Because kind of my master's was this combination of entrepreneurship and like computer science. So I really had this sort of feeling that I wanted to try to like start my own company. And with Entrepreneur First, it was basically an opportunity where you can get funding for 3 months, and depending on like so they had like 3 archetypes, they called it. So they had domain experts, who were typically people had a few years of working experience.
But how did that work? Because it's kind of a fun topic or interesting topic that I think a lot of people could be interested in understanding. But they basically have some kind of application that you can submit to.
Yeah, exactly. It's a few rounds, and then when you get in, like now I think they changed the process a little bit. They have in more cities, but when I joined, then you would get in, and then the first 3 months you would join without an idea. You would not like know any of these people, and you basically had like 3 months to figure it out. And then like while you were there, they gave you training about certain things about running a company, and then you would just like meet people for coffee and just trying to figure out what are we going to do.
So how was the interviews or the rounds, before you actually got in there? Was it testing technical skills?
So there was like there was a coding interview. So they had like quite early on they would put a label on you. So there was like a domain expert, which I was not because I had 0 working experience. I came straight out of university. They had like technical expert, I think it was called. So typically people with PhDs. And then they had this label like a generalist. So people that have just done quite a few things that can just build stuff. So the idea would be that you would join someone that already had an idea or like some experience, and you would be responsible kind of like building the first version. So then it was like a technical interview and like some of like the working experience. And what set me apart, because I took 5 years to finish my studies, and I essentially worked 12 hours a week at least along like the full period of it. So I kind of came there with like a year of working experience through that. Right. And then there were a lot of people from like Cambridge and Oxford and stuff that like had to spend all their time studying because there was so much pressure. So for me, it was kind of like I had a different background for that. So then, I had no idea when I wanted to start. So I just came there, talked to people, and then you try a few different teams.
How do you meet up the other people?
You just there all day long. So you just meet each other at a coffee machine, or you just, there was like this website where you can see everyone's profile. So then people would ask you. In some cases, they would think about an idea and then they want to pitch it to you because maybe you had like a background that maybe you could build it. So then you kind of have to juggle a lot of things at the same time. I remember at some point I had to choose between something in like computer security, and it was something for like oil transport. And it's industry that I've never worked with, don't understand anything about. So you have to like in a quite short period of time make the call, like, is this something that I want to spend my time on? Right. Do I think it's viable? Do I think this person is someone that I could start a company with? Because it's kind of like a social experiment as well, because you're trying to like, get to know each other during the process kind of. It's this trial and error. And then as soon as you start like a company or like an idea, then they give you a venture partner where you meet every week, and then you kind of like talk it through. So I started an NLP, like a chatbot type company through there with someone that I met once, and then we kind of hit it off and like, hey, let's try this. And like one of the philosophies at that time of Entrepreneur First was they push you in a team fast and just like trying to make you work it out. So then we
don't forget to take any of the awesome kind of Easter snacks that we have here. We have kind of an Easter special here, and Goran has spent a lot of time demonstrating his skills in the kitchen as well, which is impressive, I think.
So if you haven't heard, me and Anders, we're opening a restaurant in a bar in a couple of years. You're preparing for it.
Starting to train for that. So yeah,
my first proper Swedish Easter. This is nice.
Yeah, with some salmon and shrimps and a lot of cool stuff. Sill as well. So that's awesome. Awesome. And okay, so some kind of chatbot. Do you regret that decision to start a project with a chatbot?
100%, yeah.
I can imagine that.
You see like the conversational AIs that are out there now with like billions of parameters. We were very far from it. But at the time there was a lot of hype. And I remember there was a lot of these products out there where you would speak to it or you would write to it and they would kind of extract the intent. So it was very like rule-based. So based on it, and then they kind of had like an internal tree-based structure. Like, okay, if someone, because the idea was that you would also like order an Uber over like Facebook Messenger and stuff like that. That never really like took off. So then the idea was, okay, if we can know what the intent of the user is, we have some tree-based, we ask you this question, you come back, and then there's like some sort of back and forth. So our idea is, okay, if it's got to go like that, then something like A/B testing kind of things is needed as well. Like, okay, how do you navigate that tree of different options in the best possible way? Yeah. And the true goal was kind of to make sure that like the language you would choose as a company would reflect like the user that you're talking to. So a little bit of like recommender systems, kind of that kind of vibe. But yeah, there was no appetite for that. So we kind of built an analytics tool that you can sort of, all the requests you would send to us, like everything that came in and what you sent back. And then we would show you some basic stats. And then the goal was kind of that we would build up enough training data that at some point we can scale up the machine learning.
I mean, for me, you know, when I hear, you know, what companies want to have, you know, saying, okay, we want to get started in AI and, you know, what should they do? Almost, you know, in far too many cases, I would argue like 30-40% of the cases, they say, we want a chatbot.
Yes. Yeah.
For customer support or whatnot. And I just, you know, hate that kind of request because it very rarely adds any value at all. And usually it just adds customer dissatisfaction, you know, for that experience.
Yeah, I completely agree. Maybe now with the conversational AI, like the top tier ones, maybe that changes. But yeah, I also like it came off it with serious doubts. But then kind of, so after the 3 months, we had to pitch to the investment committee. And then if they agreed, if they proceeded, which in our case was the case, they invested like a tiny amount, like 16K pounds. Yeah. Where we could basically...
But didn't you get salary, you know, during the first 3 months? Or?
Yes, but back then it was very little. So I had basically to live off like 1,200 pounds per month in London, which is tough if your rent is already 900.
Yes,
Now I think they upped it a little bit, but back in the day it was not much. And kind of when we got the investment, we didn't have much runway either, so you can kind of give yourself that salary.
So you passed that test as well, so you got some investment after 3 months?
Yes, and then basically the second 3 months is more like the traditional startup accelerator, like Y Combinator and those ones where you're building up towards demo day. Yeah. And then you want to demo your product or at least a vision and then raise your first round of like external funding and then really start hiring and so on. But both of us got serious doubts a couple of weeks before demo day, but then as I said before, it's also kind of a social experiment, so we felt like we're in it now, so maybe we should just push to demo day. And both of us had doubts, but we were not honest about it, so we didn't tell the other. We both thought that the other one wanted to continue, and we're like, okay, but that's the least I can do. So then on like a Friday, I think we both came clean to each other that we had doubts, and then we knew, okay, well, this is time to quit. So then 5 minutes later, we quit the company, and that was it. And then like the startup accelerator is completely cool about that as well. Like that happens all the time, and they only want you to push through if you really 100% believe it, because it's so challenging to start a company, of course.
So you don't regret the experience of going there and...
No, it was amazing, and I really enjoyed it. I learned a lot, and I think, so then afterwards I came back to Spotify full-time. Right. And I was lucky as well, because when the summer internship started, they kind of told other summer interns that there are only 2 rules. One is that if you want to get hired, you can't have signed a contract for afterwards. You can't be having to go back to university. Basically, if you did well during the summer internship, they wanted to have the opportunity to give you a full-time contract. Yes. So for a while, I got both the offers of Entrepreneur First and Spotify, and I kind of thought that I had to choose. And then I was a bit depressed about it because both sounded like amazing opportunities. So then in the end, I was like, maybe I can just ask the recruiter from Spotify, like, can I maybe do both? And then I made an exception because he was like, yeah, you probably will find that either you're a person that wants to start a company and wants to go that route, or you enjoy more kind of like a company that is in hyper growth. And in the end, he was right to give me that opportunity because 6 months later or like 9 months later, I was back full time.
I mean, awesome. And during the intern, internship that you had, you worked with the Deep Retention Project. How would you describe that, if you recall? It was some years ago.
This is a trip down memory lane. This is interesting. Yeah, I remember that the goal, so we were both part of like research analytics, so it was basically trying to analyze why people were churning, why people are using Spotify, and we had we could send them emails to remind them to use it, or send them like a discount or something. So it was basically, the idea was, okay, if we can learn what these points are that they maybe drop off, then maybe we can nudge them slightly with some sort of discount or something, and sort of see if we can get them engaging back with the tool. So we had a ton of data. It was also the first time that I realized how much data that was out there and how challenging it was to like process all of that. So we trained, I think it was like a recurrent neural network that tried to predict on like a day-by-day basis if the user would still be active on the day after. And then quite soon after, I also realized that just training these models was very challenging. Getting the data was challenging, so it was more like an engineering issue than maybe like a machine learning issue.
As AI often is,
yes,
right?
Exactly. But this was my first true experience with that. So and then I think it was super valuable.
And it was this kind of wide and deep learning model, if I don't recall. Yeah. Right? How would you describe that model? What is wide and deep learning?
So I think it comes from like the recommender space, where often these deep neural networks have a challenge of learning higher level interactive features. So if you have a user, like what is the interaction between like their age and the genres they like, or the country they're from? And just by giving the model these raw two features, deep neural networks have a hard time learning that automatically. Things like gradient boosted decision trees, like there are other types of algorithms that have a much easier time to learn these kind of combinational type things. So nowadays there are algorithms that can kind of learn these things automatically. But back with wide and deep, you would program as the engineer, okay, what are these cross features? So these features that cross multiple things that could be interesting, and then pass that to a separate part of the network, kind of to give the model an opportunity to sort of give them that information up front. And then typically they started to perform much better.
Yeah, so I saw some quote. I mean, it's trying to find a good mix between both memorizing the data, but also generalizing from it. Right?
Well, it's interesting, though. I completely forgot that it was wide and deep, because I'm actually, so now we're working on a machine learning modeling library for recommender systems. So one of our tasks on our board is actually to implement the wide and deep model, even though that we know that it's not performing as well as like some of the other models, but we want to kind of have it as a benchmark. So it's
it was a big thing, I guess.
I think Google was one of like the first models they found that actually were because before for tabular data, like the deep neural networks always had a hard time outperforming these more simpler algorithms.
Cool.
Which is still a topic till this day, but we're slowly getting away from that. But
and tabular data is surprisingly hard for deep learning networks, or that's not really where they shine, at least, right?
Exactly, and I'm actually personally on a mission to try to change that. So that's kind of like for the last year, I've been working on like deep neural networks for tabular data. So this is kind of what I spent most of my thinking cycles on nowadays, and we're making progress, but there's still a long way to go.
I add that as a topic. I think that's super interesting. So awesome. Okay, so you did the internship. You went to Entrepreneur First, which was in London.
Exactly.
And basically, you try to meet up with some people, and you start some kind of startup. You get some funding, and then potentially, you see how it goes. And you chose chatbots, which is perhaps not the best thing.
No, looking back at it, I'm regretting that choice a little bit, but it was valuable for sure. Yeah.
So you would still recommend other people to try it if they get the opportunity to.
Yes, for me it was, so since I kind of had this dual interest between like entrepreneurship and engineering, through that experience I also realized that I had much more joy out of the engineering part, and like kind of an artifact of running a startup like that is that you spend a lot of time, if you start scaling, on hiring. And especially for like a machine learning type startup, like you spend a lot of time getting the data or the app in a place where you can start to do machine learning, where it actually makes sense. Because in a lot of these cases, like these companies say they're doing all these advanced machine learning, but there's actually a very simple rule-based system, but they always have to go at some point to change that. So for me, it felt like if I really want to get more knowledgeable in machine learning, like this is not for me the right way to do it. So then it was much better to go back to Spotify, where I can actually focus on these things on a daily basis, which I thought then I could work on machine learning all the time. Even that didn't turn out completely true, and I had to make some detours in order to get that to work. But yeah.
So what did you start working with at Spotify when you went back there after Entrepreneur first?
Yeah, so when I worked with you, it was more on sort of analyzing the user behavior in order to get them more engaged. When I moved back, I wanted to work more, I wanted to have more like a product impact. I'm using Spotify all day long. It's probably the app that I use the most. So I was like, I want to work closer to the product.
Sorry, you have a good or a strong musical interest as well, right?
Yes, yeah. I think I'm like listening to music during coding all day long. So I think I'm always in like the top 3 or 5% or something when the most amount of hours per year. I always have like 100,000 hours or something on a yearly basis, which is a bit crazy, but yeah.
What kind of music are you interested in?
I think if you would analyze my music on Spotify, it's a lot of electronic music that I listen to during coding. I have this weird habit where I repeat songs very often if I'm in the zone, and then somehow if I hear that song again, or like a few songs, and then somehow at some point I don't hear it anymore, but then I'm truly focused. It's weird. So sometimes I can hear like a song like in a bar or something, and it takes me back directly to like a coding exercise, or sometimes something on university where I just like repeated that song over and over again. Which is
cool. And do you think, we had actually a surprising number of guests on this show that have both technical interest and also a very strong musical interest, and not the least Goran here himself and Henrik and others that are which are lucky enough to be talented both in music and tech. I want to be, but I'm horrible. The only thing I can do is bad karaoke. But I wish I could, play an instrument or be more musically talented, so to speak. But do you think...
I remember those karaoke days. That was fun.
Yes. Do you think there is a correlation between people that have, interest in music and interest in tech? Are they like a causation between them, or what do you think?
I think so. I think coding and tech is often more creative than people maybe think from the outside. Like it looks very hard science, but if you start to look into it, like if you engineer a system or also on the machine learning side, trying to figure out what would work on this algorithm, like it's like the creative element is a lot. And I think, so I got like when I was in high school, I had my own little music studio in the basement and stuff, and I just like...
You played instrument as well? Or?
I played a bit of piano and I played the drums. Yeah. So I was mostly producing like electronic music, and I think there's a lot of similarities with coding, which is also the reason actually now that I'm not producing music anymore, because it kind of I use my same part of my brain from it that I use for coding, and now I was like, I'm doing that too much. I don't get any pleasure out of it anymore. But there is like this long tinkering with stuff, like how does it sound if I do this? Maybe a little bit of this, like going deep into like the sound designs and the little, like the large amount of virtual instruments that you have, which is a bit similar to now, like the large amount of different tools that you can use in order to do machine learning. So I think, for me, it's the exact part of my brain that liked music as well as coding.
What do you think about that trend? Spotify, for one, is very strong on we're promoting not only listeners to music, but also the creators of music. And there is also a lot of research in using different AI tools to allow people that may not have the talent to play an instrument, but still be able to compose music and produce music in different ways. Do you think that's good or bad things? As some creators think it takes away the...
Yeah, I guess it's more like the purists that have an issue with that. I have no issue with it personally. I think often I heard people at Spotify make the comparison between what kind of Instagram did for photography, where everyone is a photographer now with like these different filters. They were kind of looking to sort of create that similar experience for music by making it as easy for people to produce like good sounding music. I think it's a different, like it's different than just like the purist, but I think there's a place for it, and especially now with when the AI starts to like become more and more powerful and sort of the TikTok of this world, like it is. Yeah, I think that the youth, like I sound very old now, but like when I talk about TikTok and stuff, I do feel old. That's weird, but
imagine me speaking about TikTok. That's yeah, wouldn't you think that potentially it's a way to democratize basically music by giving some? I remember one of the first like AI-enabled albums or created albums. Amy or something, I don't recall the name.
Right.
But she used some software to produce, all the orchestra or the instruments, and it could basically produce it through that, and she could add some vocals to it. But in that way, she said, she always wanted to play some instruments, but never had the talent to do so. And
Right.
But now suddenly this opened up a new world where she can actually express her, interest in music.
Yeah, and it becomes a different game, right? Like instead of having to have that hard skill of playing an instrument, is more like your taste and your intuition sort of guiding the algorithms to something that sounds good to you.
Yeah.
So no, I think it's super interesting. I think we'll get there. What the implications are for artists, I'm not so sure. I think we've seen it at Spotify, of course, as well, with this study and piano music, where it's been people care less about the artist and just like the sounds, and it's easier to make. So it's there will be some negative elements, I guess, for artists, but they were always having the counter argument at Spotify for Instagram did photography, that it also led to more people getting really interested in sort of like old school photography. It led to more cameras being sold. So it's also, people see it from like a different lens, I guess, literally in this sense. So that could happen for music as well. So I don't get pessimistic by it, or I'm not a purist in that front, that I think that we shouldn't change these ways, because of course it's painful to learn an instrument. It takes you multiple years to get decently good. And there's only so many things you can do on a daily basis.
Cool. Well, then you started at Spotify, and you worked with the Tunigo team, if I'm not mistaken.
Yes.
Can you just describe shortly, what kind of product did you work with, or what's the type of functionality?
Yes. So Tunigo was the first acquisition that Spotify made, and basically when I was there, I think there were like 150 editors at Spotify. Basically, their full-time job was creating and curating playlists, and they had a very prominent view on a spot on the homepage.
Right.
And it was things like Rap Caviar and like a few others as well. And back when
it was one of the biggest playlists there. It was something about coffee house thing.
Coffee, yeah, I think so. Yeah, coffee. Your favorite coffee house.
Yeah, right.
There were a few of those, and basically they had just like different editors in different countries for different genres, and depending on like how big the country was, they had more editors working for them. And when I started, the editor was controlling the whole playlist, so they were also in control of like which songs are in there, but also what should be the position of each of these tracks.
Right.
And like the project that I worked on like for a while for Tunigo, which was kind of like a company bet, was like Algotorial, to get more algorithmic parts in these playlists. So then the idea
I think we need to repeat that. I think it's interesting, the Algotorial.
Yes, so editorial with algorithmic. Yeah,
yes,
they are very good at inventing words.
Semi-automatic playlisting, or
exactly.
I mean, they called actually that programming, if I'm not recalled, which actually made me a bit, confused to say that programming is about, playlisting. But
exactly, I guess that came from like the radio industry. They call it like that. But yeah, they were often people that had backgrounds in making like curating radio shows. And like the interview process they had was very interesting, where they just got like a theme, and then they got like 20 minutes and they had to make a playlist, and they were judged from that. So it's very different from how you would be judged when you would be coding.
So, and when you do that, you basically have to choose the songs, as you said, but also the position and the ordering of them, right?
Yes, that's how it started. And then the idea was that they would not create playlists anymore, but they could create pools. So the pool would be larger than the playlist. Let's say the pool would be a few hundred tracks. But for each individual user, maybe only like 25 or 50 would be shown. And then there would be an algorithm deciding on a user-by-user basis which 25 or 30 that the editor could set, but should be the playlist length, should be selected. And then the algorithm would do the optimal ordering, at least what it would believe would be the optimal ordering. So it would add a little bit of personalization to that, but still having highly curated tracks in that pool.
The selection or personalization of that kind of programmed playlist, if you call it that, or I mean some kind of manually programming of a set of 100 tracks or something, and then personalized to like 20 songs. That was based on the collaborative filtering vector, right, that they had? Or?
Yes, like the word-to-vec type things. That's how we started, and I think then over time we wanted to make it more dynamic, because like one of the implications of that is that like if the user gives direct feedback for that individual playlist, there was no way to act on it.
Right.
So then we wanted to change that to get more like a tighter feedback loop, where if you dislike a certain track or like you don't play it even though it's on the first position, then we wouldn't show that again. But that was kind
perhaps
of
we need to unpack that a bit more. Why it's hard to give feedback and
right.
I guess, a simple way is to say you basically have a vector per user saying this is my taste in some way. And then you have the songs and you simply choose the closest one, perhaps with some diversification or something.
Exactly.
But then if you give feedback saying I don't like this specific song, it's hard to include that in the algorithm, so to speak. Or how would you...
So in this sense, let's say you're playing your favorite coffee house and there's a track on there that you don't play on the first position. And people, the position is super important. So the higher the track is, the higher the likelihood is that it's being played. Doesn't necessarily mean that it's a higher quality for this user. They just click on the first thing that you showed to them.
Right.
So if you then don't play that, that probably doesn't have enough of an effect on your taste in general, because every song is 3.5 minutes. So you have to take quite a few actions for that to sort of go into your long-term taste. And it could also be that that track that is on the number one, you've already listened to a few times, or maybe doesn't fit that mood, what this playlist represents for you. So maybe in certain contexts you want to listen to a certain track, but in other contexts you don't. And with that sort of general taste vector, you won't be able to do that. So then kind of you need a sort of tighter feedback loop. But if this user is in this context, in this playlist, this is what it typically listens to, and therefore we sort of boost this track over this other track.
And this kind of algotorial, I think it's a term that is interesting, and I think Spotify coined it. I'm not sure if...
I think they coined it, yes.
Did they find a way to make it more, editable in some way?
I think right now it's much more editable, So I think they're moving to get more and more of the feedback of the user, kind of what TikTok is doing, sort of make things more reactive and trying to act on it directly. But it's a hard problem to tackle. Also, just... you need to log everything correctly, and you need to make sure that the algorithm is then taking it into account in a timely fashion. So from an engineering perspective, it's much harder to pull off. I think it's an ongoing basis, but it's already much more reactive as it was before.
You mentioned TikTok, and I'm eager. Do you know the details about how that algorithm works? I heard some stories about that, but I'm not really...
I've only basing it on the public research that I've seen, the papers that they published. I think... it's similar in a way from what Spotify is doing, in the sense that maybe Spotify's algorithms were not top-notch, but the data set that they had was so high quality that even relatively simple algorithms were performing amazingly well. And I think that's true in a way for TikTok as well, because every video is only 10 or 20 seconds. So if you think about it, if you compare Spotify to Netflix, where a movie or a series is tens of hours. A movie is 1.5 hours. So the amount of actions that you can the amount of feedback that you can give to the algorithm is relatively limited. Spotify can already do much more because every track is 3.5 minutes. But if you cut that down even more, then you get so much data that it's also easier to act on.
But wasn't TikTok a more content-based type of algorithm rather than collaborative filtering?
I think so. I think they've done a lot to make it more enable more organic growth, that it's not only the top influencer taking away everything, but they want to ensure that a small creator can still make it all the way to the top. So I think they ensure, but I'm not sure if that's learned or is it more like a rule-based system that has that type of diversity.
Perhaps we should unpack, what I guess these are the two main types of recommender systems you can build, like collaborative filtering versus content-based. How would you describe these two for people that haven't heard these kind of terms, collaborative filtering versus
collaborative filtering is kind of trying to look at users that are similar in your behavior and then seeing what they like and then giving that to you. So if our taste 80% match, but we have on top of that some different tracks that we listen to, then we can recommend these tracks that we haven't played to each other in order to see if we like that. Content-based is different, where you either try to describe the content, try to manually put it in different buckets. I remember when we were at Spotify, I think it was Pandora had this whole genomics type thing where they had this they're trying to break it down.
Genomics of music and
exactly,
So genome or a lot of data about each song and artist and everything.
And then trying to see based on what you liked, what are the closest in content to that.
And that can be metadata around the song, not necessarily the actual content.
It could also be the audio if you want to push it really far. There's what kind of tracks sound like each other. In music that is relatively hard to do. You need to have a pretty good understanding of the track in order to be able to do that. But there are definitely ways to do that. And I guess it's also more of news type things where you can look at the word counts and the topics, and then you can sort of, based on this topic, things in another topic you can recommend as well. But for music, it's typically a little bit harder.
Awesome. And then you worked with playlisting there at Tunigo. What was it still called Tunigo at that time? Or
no, they changed to like programming platform.
Yeah, right.
So when there were like 4 teams when I was in there, and then often like that these company bets, so they had like a bunch of teams working on that together. So for that project we worked with a bunch of teams that were based in Boston. And then like my work, so the algorithm part was pretty simplistic, and we're basically just reusing what Spotify already had. So there were like infrastructure teams that were basically publishing these vectors for the whole company, and we were using that. But we didn't have enough resource to actually make meaningful improvements to these machine learning algorithms as a team, because kind of the strategy that they use at each team as a squad should be super autonomous, which means that each squad only has like 1 or 2 machine learning engineers tops. And for other type like front end or back end, typically that is enough to make meaningful improvements. For machine learning, it's typically not enough, especially since machine learning was still pretty new at Spotify. So we struggled a bit with that. So then in order to get more exposure to machine learning, I actually started working more on like the infrastructure side. So I embedded with a team in Boston and New York for a while. And then I built this little prototype that would make it easier to run like an MLOps type framework, to make it easier to transform your data, train a model, and evaluate it all in like a same pipeline, all in like Python. So basically targeted to machine learning engineers and in the tools that they're working with. Because typically at Spotify, for instance, you have data engineers, they write their things in Scala. And you have machine learning engineers who typically write their things in Python and other frameworks. And it doesn't always match. So the only people that could really get things done were machine learning engineers that worked there for a while, had enough understanding of the data pre-processing and like all the different systems. But for new joiners, it was typically quite hard.
So I think you go through this very quickly, so it can be, I think, hard for listeners to understand.
Yeah, slow me down wherever you think it will be more explanation needed.
But just to reiterate a bit more here, I mean, for one, you will work with a programming platform team, but that's not really about coding. It's about the playlisting part, right? But then also, I think you mentioned a very important point, which is that if you have a squad that have some, responsibility and ownership of, let's say, playlisting, then, and you just have 1 or 2 ML engineers working there, it can be really hard for them to contribute to some like core machine learning algorithm system, right?
Especially in the beginning of a project, you're still trying to get the data in the right shape. You're trying to make meaningful improvements, but then you're not training your own models as a team, but you're using someone else's models, and then you're kind of trying to influence that, which can be challenging. And typically you just don't have enough time to really prioritize working on your own models and pulling all that off. And I think what I identified, and many in the company identified as the key issue, was just like it was too painful to do this all by yourself. There was no good infrastructure to do this.
So how do you build a team that can really work on improving like ML models in a good way? I think Spotify's take on it is that they don't want to have centralized modeling teams, but they want to make this as close to like the domain experts, which I think is a good argument. But that only works if there is enough infrastructure in place to make it possible to make meaningful improvements on this model with only 1 or 2 people. And this worked very well with like standardized infrastructure for like back-end programming, so the things that are running on the server, for like data engineering, for front-end. So they had all these frameworks in place that kind of standardized how things were done for a particular like type of engineering. And then they were able to sort of make meaningful improvements with only 1 or 2 people. But for machine learning, for a long time, we were definitely not there. So I spent a bunch of time trying to design tooling that would enable that, so that it would be possible for teams to do way more things on their own and be autonomous and train their own models and make their own decisions around how to evaluate these models, how to pre-process the data for it, and so on. We actually had one person that come from the same country as you, from Netherlands here, Jan Bosch. I'm not sure if you know him.
Never heard of it. It sounds like a Dutch name, though.
So he's a professor in software engineering from Chalmers.
Okay.
But he focuses on AI a lot, and he coined, I'm not sure if he coined it, probably not, but he speaks and actually do research in what he calls AI engineering. And he tries to argue or try to discuss and find, what are the differences between traditional software engineering, like back-end, front-end engineering, etc., or data engineering, compared to AI engineering. And then one of the conclusions, anyway, one of the findings, I guess, is that AI engineering has a lot of challenges that traditional software engineering does not have. And it would be fun to hear what you think about what are the main differences between like traditional, if you build a mobile app or website or like a database-based backend system or an API or whatever, compared to like a heavily machine learning model-based kind of system like a recommender system. One thing, I can start to just give some points, and please, let me know what you think about that. But one part, at least, is that in traditional software engineering, everything is hard-coded. Basically, you have to write, the code yourself from, not from scratch, but you have to at least use the existing libraries and code out there and write everything manually. And one way to define AI would be to say that AI, or at least machine learning, is about really trying to automate a small part of that process, to instead use data to automatically infer the rules of that. So in that way you can start to build recommender system or image classifiers or whatnot. So, but that also means that you have a new dependency that you've never seen before, which is data. And you never know, I would argue, if something will work until you tried it for your use case on that data that you do have, which is very different from traditional software engineering, where you at least know this is something I can imagine the rules to be, and it's a bit easier potentially to plan or foresee if something will work or not. Would you agree with that?
100%. I think sort of the experimental part of it is a big factor in this, where you just have to try it out. And even if you sort of seen something work and something that is very similar, you can never be 100% confident that if you just change that system to use your data instead, that you would have the same amount of success. You need to understand the data pretty well. You need to understand like the algorithmic choices that you have to make. So it's much more trial and error than maybe normal engineering is.
Yeah. Another claim potentially would be that the tooling around like traditional software engineering is rather mature. Yeah. We have rather good tools when it comes to testing or when it comes to just the development environment that you do have, or CI/CDs and DevOps potentially as well. Right. But potentially for AI, the tooling is much more immature. Would you agree with that as well?
100%. Yeah. It's all been developed in the last few years, and especially for like tabular data and recommender systems, like there's not much out there that you can just use and it will do everything that you need to do. There's a lot of like custom engineering that you need to do on top of it in order to get like an end-to-end system in place, because it's typically pretty complex. And it's the exact problem that we're trying to solve it with NVIDIA Merlin, where we're incentivized in a way to do this, because we don't have skin in the game in that sense that we don't have our own competing service. We don't have any recommender systems on our own. We just are interested in sort of bringing the space forward and making sure that companies can build these things on their own with their own data.
I was thinking that. You are exactly doing that right now, trying to improve the tooling around the recommender systems at NVIDIA right now. Right. But before we go there as well, so you moved to this Boston team as well, and you worked a bit closer to the infrastructure part of the system, right? What was that more specifically?
Yeah, so it was a team that would do more sort of general machine learning on like promotions. But my
promotions like ads or stuff, or what?
Yeah, exactly. I think this was like a few of like emails for like promoting concerts, and we had a few of those projects that were kind of like one-offs, and we would use like different types of models. And I joined more as like a machine learning engineer, focusing on sort of building this tooling, because I was very frustrated at that point that it wasn't working as I wanted to, and I couldn't work as much on the machine learning side as I wanted to. So I worked in this team, and I built this little prototype. So we had this Python library called Luigi that was basically doing sort of data engineering pipelines. So I coined this tool Mario that was kind of like a Python type framework built on top of like Kubeflow and some of the tools that just were open source by Google that they were using internally to have these end-to-end systems that you take in a bunch of data, and it was all kind of standardized what was happening in that pipeline. So there was you had different components, and you could extend it with your own components as well. So you had data coming in, then it would generate all the statistics. So you had like a visualization where you could see the distributions of the different features. To kind of see what you could do with it. Then it would infer the schema, then it would train a model on it, and then it would evaluate the model.
I guess we're speaking about Mario now and not Kubeflow directly,
right?
So
okay, I will go a bit more in deep like what Mario was doing. But so they had this thing called TFX, which is basically coming out of Google, where they had all these components. And at the time,
And that was TensorFlow extended, right?
Exactly, TensorFlow extended.
It's more like a framework around the TensorFlow network to have the additional tooling.
Exactly, and primarily targeted for like tabular data, which is kind of what recommender systems all is. You have certain types of properties of users and of items, so they're all different columns. You can kind of see it as one big Excel sheet of different properties that you have. You're trying to learn from that what the chances that a certain user likes a certain item, kind of, and you can describe that item and user with different properties. So this system seemed very promising, but when it started, they just wrote a paper. So they described the system, but they didn't open source it.
You mean Kubeflow now?
Sorry, TFX.
TFX.
So like TFX was these components, and then Kubeflow was more like how you would execute these things on Kubernetes. So like, it gets technical, but like how these components are being run in the cloud, kind of. So we're two different systems, and they were both very promising, but there was not one tool that can use both of them at the same time. So make use of the TFX components, but then execute them using Kubeflow. Because Kubeflow then allowed you to have like a little UI. So you had like a user interface, you get like a website where you can go to, and you could see like a visualization of your end-to-end pipeline with like the different outputs, and you could see like kind of the like all the results of your model.
And that was open source as well, Kubeflow, and
yes, Kubeflow and TFX were both open source, but barely any documentation, and they didn't work together.
What do you think about Kubeflow pipelines? You know,
that was the project. So it was Kubeflow pipelines.
That was what you worked with. Okay.
Yeah, exactly.
What do you think about that? I have mixed feelings, I must say, about the Kubeflow pipelines part.
So it's basically you can run a pipeline of these different steps, and then each step runs on Kubernetes in like a Docker container. But it made it very challenging to, like, I have some code on my computer that I want to run. How do I get it there? Because there was no way of like automating that, like this code should go in this component and then you should run it, kind of. You all had to do like manual steps where you first build a Docker image, then you like publish it, then you change your pipeline to say, okay, this is the Docker image that I want to use, and it was super manual.
And was it YAML file or XML files?
Exactly, yeah.
YAML files, right?
Yeah. So like that was a tool that I built, got rid of that kind of. So we would build the Docker images automatically for you, and would basically do all the YAML generation on the back end. So all you had to work with is just like a Python pipeline where it just does it all for you.
That makes so much sense.
And then kind of that grew into, so I did this little prototype, I demoed it to some people, and then it was like there was like an ML platform team as an infrastructure team that was focusing on making sure that there would be better infrastructure for the whole company that were doing sort of end-to-end pipelines for machine learning. So they saw it, and then kind of I worked with them for like a year and a half to sort of build this out towards becoming like a core element of like Spotify's like managed machine learning infrastructure. And it might still be running today, but
that's awesome. I'd like to just linger a bit longer on how do you do configuration management properly. And I've been tearing my hair off a number of times when trying to configure different Kubernetes cluster, and 20 different YAML files that you have to try to see some kind of this has to have the same name there and this one in the other place, and even at some point you can do if you use like scolding. No, not scolding. What's the name for the thing that you can use to? I forgot. Anyway, you can have these kind of tools to operate and replace parts of old YAML files. So we basically have
JSONnet or something. I give a few of those, right?
No, it's I don't. Anyway, you can basically put programming operations inside the YAML files. So you say replace, and you have some kind of like identifier, and they basically try to, in a YAML syntax, do programming. And I think that's so completely wrong, to be frank. And if you do programming, you shouldn't use a YAML.
I agree.
And I think also, even without doing programming, still having all these kind of YAML files without the possibility to reuse them, which normal programming languages can do much better, requires you to have so much boilerplate, so the whole like configuration management becomes super complicated.
Right.
What do you think about it? I mean, why
I hate YAML. So like for me, it needs to be all like a programming language. So we do everything in Python.
Yeah.
But like provisioning these clusters is super painful. So the way Spotify sold is that like that machine learning infrastructure team deployed multiple clusters, and then the entire company was using those. So they kind of like automated that all for you, which makes life much easier. And then we had that tool that kind of just built the Docker images for you, compiled it all down to like the YAML representation of the whole pipeline, and then uses Kubeflow pipelines to execute it. So then as a user, you don't have to worry about any YAML at all. And it's just all Python, which is kind of the language anyways that engineers or machine learning engineers are most familiar with.
Sounds like a dream, I think. Cool. Is that open sourced yet?
No. Okay. It's not. If I would build it again, I would build it differently. Let's put it at that. Okay. But it worked reasonably well. But what I realized is that it was heavily targeted towards machine learning engineers. And then for machine learning researchers, it was super painful to use because they often don't have knowledge about Docker, don't have knowledge about Kubernetes, and they don't just want to think about it. And like they don't really care about a production pipeline either. They basically, what they care about is, okay, I have this data, I have this model, this is how I want to evaluate it, run it for me in a good way, and kind of almost like a Rubik's Cube with like 3 different dimensions. They want to change the data set, they want to change the hyperparameters, or they want to change like the model architecture. And that's all you need to give them, kind of. And this tool didn't really allow that.
I mean, I think this is such an interesting topic with thinking, traditional software engineering, nice, easy tooling. You basically said before that you could potentially do some like front-end engineering with just this 1 or 2 person in a squad, because in some way it still works. You have more maturity, I guess, simply, so that works. But it doesn't really work for machine learning. And what do you think about the future? If you think ahead, I mean, I can imagine so many companies that have gone through this problem specifically, and they have 1 or 2 data scientists or machine learning engineer that may be good at the theory or using notebooks, but don't really know the tooling around building proper systems. Do you think there will come a place where machine learning will be as easy to work with as like front-end engineering, so you can really have like a single machine learning engineer in a team and it still works as good as it does for traditional software engineering?
Yes, I do think so. Yeah. But so like if we go back to like that system that we had at Spotify, initially I thought all it will take is just giving one machine learning engineer in Python the opportunity to change all parts. So they should have a way to change the data, join in different sources, transform it slightly different, add some new feature sources, all of that. They should have a way to change the model, and they should have a way to like evaluate it slightly differently. Right. And that's kind of all they need. Yeah. Then I realized when I build a system that could do exactly that, which often the case, then the next bottleneck starts to show up, right? Yes. Like your system is only as good as your weakest link, of course. And in that system, it became the runtime. So the computation time was just way too slow. So all these individual steps were using data flow under the hood, which is this technology from Google. Yeah. It's basically just MapReduce type jobs that run sort of
similar to Spark and Flink, I guess, but exactly, it's the managed service in Google Cloud.
Yeah, so basically as an engineer, you have a way to program in a certain way that you can easily distribute that over multiple different computers, different servers. And this tool helps you kind of say, okay, I want to run this program on 100 different nodes, and it will just provision all that for you, run the program, and then remove all the nodes afterwards. Yeah. But it was all written in Python, so it was relatively slow. So then I finally had a system where, as an engineer myself, it wasn't the easiest to use system, but I was at an advantage, of course, because I built large parts of it. So I was at least able to use it. So I could transform the data, I could change the model and do the evaluation. But then the problem was that the whole end-to-end pipeline took like 24 hours to run on like a reasonably sized data set at Spotify. So let's say a few 100 million rows. That is very challenging because that means that you can't even like do it on a single workday, and even on 2 workdays, it's tricky. So then what ended up happening is that the data we would, like up front, we would say, okay, these are the features that we want to experiment with. We would run it once and we would not touch it anymore. So then this sort of pipeline that you have of transformations, model training, and evaluation, you kind of only focus on the last 2, which you know that you only get like a certain amount of like performance, of course, because you're ignoring like a large part. We can actually make meaningful differences. And even that last part took maybe 7-8 hours for training, 3-4 hours for evaluation. So even that didn't fit in like a single work day. So then it's like, okay, now I have an environment where I can change everything, but I have to wait so long. So it seems like, okay, it's actually a computational problem. And then when I was at KDD, one of like the large conferences, and that was for the first time I got demoed like NVIDIA Rapids, which is essentially sort of a library. So if you do any data processing in Python, you only do that in small scale. You have this library called NumPy, and you have this for like arrays, and you have this library called Pandas, which is more for like kind of Excel type things. But all the data needs to fit in memory, so you can only do it for large scales. But then it's reasonably fast, but you can only work maybe like 100,000 rows or something. And then NVIDIA showed this tool where they implement the exact same APIs of these two tools, but they all ran it on the GPU. And they could actually scale to much larger data sets, because over the last few years, the amount of memory that in these GPUs like grew a lot. So that for the first time, like I built then a tool at Spotify that replaced some of like the tools that were using the MapReduce to move it to the GPU. And then I ended up with a pipeline where the end-to-end pipeline maybe only took like 5 minutes for something small and maybe like 30 minutes for something big. So then finally we were able to like multiple iterations on a single day, which is kind of the exact, like I guess around the time that you were there, it had a similar thing where it started with like MapReduce and Hadoop, and ended up being BigQuery, where it was also that 10x speed up, and then all the data scientists,
100 or 1,000 times
exactly
speed up,
and that made all the difference for them. So I was kind of okay. I think in order to push it forward, it's not only an API problem, but it's also just a runtime issue. So
awesome. And let's move into NVIDIA, I think, as well. Any last like highlights from Spotify times otherwise that you'd like to mention before we move on into?
I had a great experience there. Like especially like that first couple of months when you hired me, I really felt like a kid in a candy store, and like there was like the office was nice, and like there were so many parties, and it felt like a very vibrant place. It changed a little bit, of course, with COVID when everything was remote, and then like the company kept on growing as well. But overall, I had like a great experience there. But at some point, I just realized that the things I was more interested in sort of creating infrastructure that was more like generic, and there were not that many opportunities at Spotify anymore, because Spotify a couple of years ago made the call, okay, we're like everything low level, we're not going to do ourselves. We're just going to use Google Cloud. And that means that for me, building those tools, there was not that much appetite for, because there was always something at Google Cloud that could do that. I was never so happy with like the solution. I would like to change it, but it's hard to do from the outside, of course. So that was one of the reasons that I made the jump to NVIDIA, where it's all about the lower level infrastructure.
Cool. And then you got into NVIDIA. And what did attract you to NVIDIA? Was it specifically this, that you could actually work with more, what should we call it, infrastructure or low-level functionality? Yes,
and also just like a change of kind of variables that you can work with. Like at Spotify, you can kind of look at it as like unlimited amount of data, but the compute is relatively limited. It's like if you're a single engineer and you want to learn more about machine learning, you want to scale up your models, and you want to use like GPUs or like specialized hardware to do so, the price of these things are super expensive on Google Cloud, which basically means that if you really want to like get like a tight feedback loop where, okay, I change one parameter, see what it does, you really have to spend like millions and millions of dollars on Google Cloud, which I would never get the approval for. And that makes sense, because business-wise, you shouldn't give me that flexibility. But NVIDIA is different, of course, because there we built the engineering, we built the hardware. So I basically now have unlimited amount of compute. I have like a big machine with.
Can you run some models for me as well?
Sure, yeah. But,
that sounds great.
Yeah, we'll run faster than like the dummy version of the GGX, I think. But like the sort of the sad part is that I don't have unlimited data anymore. I have to work with public data, so that makes it sort of
the trade-off, right?
Exactly, it's a weird trade-off, and like we like. Part of the fun, of course, as well, is like building recommender systems that actually are out in the wild and sort of you can interact with and have impact on people. Right now, we're much further apart from it. So we know that companies are using our tooling to build recommender systems, but we don't really know how. Like they are telling us. But like,
can you describe that as potentially? At Spotify, it was more B2C. I mean, you built the product for an end user in some case, and you could measure the impact it had or user experience in some way. But now you're more building code or products for other companies, more or less. It's more B2B. Would that be a fair description?
Yes, although there are a fair amount of infrastructure teams at Spotify as well, and which I was working at like for the last 1.5, 2 years. But then you still had the opportunity, so like all code at Spotify is hosted on like a private GitHub, and everything is kind of open to when you work there, which means that like you know exactly how each team is using your tool, and you can use that as kind of like, oh, they're using it wrong here, or actually their use case is slightly different, so you can learn from it. Then you can sort of improve your tooling. That is much harder now, because now I don't have a search bar where I can just type in, give me everyone that's using my tool, and then let me learn from that, which makes it more challenging.
How do you interact? I guess we should wait with that. Add that as a question.
Yes.
How do you interact with the users of Merlin, etc.? But perhaps we should first move into that, because you got started working with Merlin directly, right?
Yes. I got hired in the Merlin team in May last year, so I've almost been there for a year now.
And what is NVIDIA Merlin?
So it's basically an open source framework for end-to-end recommender systems. So the idea is that we want to utilize GPUs and build tooling for companies that they can train their own models on their own data for recommender type problems. And when I joined, there was only one team, kind of the data, or the one product, the transformation, and now we're expanding it. So we're more and more moving to sort of having tools for all the different parts of like an end-to-end recommender systems project, so to say.
And what are the different components, basically, that you are working with?
Yeah, so if you have like the inner machine learning loop, as I would call it, so it's basically data transformation, a single model training, and then the way you evaluate that model, which is kind of, we already had the transformations. I've been working from the start on like Transformers, Rec, and Merlin models, so building machine learning modeling libraries. We have a little bit of evaluation metrics and stuff in there, but there's much more we can do. And then more and more, we're also kind of working on kind of the outer loop, I would say, of machine learning tooling, where it's kind of putting it in production. So if you think about an end-to-end recommender systems problem, we typically like to frame it here at NVIDIA like in 4 different parts. So there is like the retrieval, there's the ordering, there's the ranking, and then there is there's the retrieval, then there's some sort of filtering, then there's the ranking, and then there's like the ordering. And so there's
what is the difference between ranking and ordering?
So typically, if let's say, for instance, that you have a single model that makes a prediction, but you're a Spotify and you also want to, which is kind of a score, like how much does this user like this item? But we also want to ensure like artist fairness and stuff like that. So there's like different constraints.
Post-processing?
Exactly,
ordering?
yes.
Okay, so ordering is a
kind of like
post-processing
business logic. And there's like a filtering there as well. Like let's say you filter, you want to recommend a track to a user in a country where that track is not part of Spotify, which happens because there's like a very complicated system with record labels and stuff. So there's often business logic that you need to apply after you get the results of the machine learning model.
So how would you describe the different parts? So retrieval is basically given a huge set of songs or whatever. You get some kind of query into it or something that you feed in, and then the retrieval part is simply collecting a big set of candidates, or how would you describe the retrieval part?
Yeah, so if we would go to the ranking, typically it would be a user with all the features, an item and all the features, and you would get back a score, like how much does this user like this item following this algorithm. But if you have millions of users and you have millions of items, you can't just run that algorithm for all possible combinations. That would just be computational, like that would never work. Yeah. So there are these special type models, which is like this, where you can kind of embed both the users and the items in a vector space, where kind of how much a user likes an item.
You can say what they are called. I think it's important to know.
Yes, so you have like matrix factorization, and then you have a sort of more generalized version of that, which is called like a two-tower, which is basically you have matrix factorization, you have a user ID, you have an item ID, and you learn somehow like to predict what the score will be based on data that you observe.
Two-tower, but I thought factorization machines is also a part of it, or is that different from this? Or?
It's fact, yeah, it's like a special type of models, which is we can talk about that as well.
What's the two-tower thing? I guess matrix factorization is rather well known. But
yes, two-tower is basically the generalization of that in the deep learning fashion, where you don't only have a user ID and an item ID, but you also have user features and item features. So the user features are all going to one deep neural network that outputs a vector. Similarly for the item ones, so the user and so you get two vectors in the end, which is exactly what you would get for a matrix factorization, and then everything just follows through. So it's just essentially you have this extra element where you add more features towards it, and you use a deep neural network to learn the representation.
So to give it a concrete example, then you could have like songs on Spotify. You have the user IDs, you have the item IDs, which are the songs. And then you can have features like, I guess, the genre of the song or something?
Exactly, genre of the song, when it was released, maybe the artist, and then on the user side you might have like demographics and like a few other things that describe potentially the behavior of this user.
Right. It sounds very similar to factorization machines in my view, but okay. What's the difference then to factorization machines?
It's similar, but the factorization machine is more like you learn higher level feature interaction. So it's a different type, a certain type of like a model architecture, where that you typically can also use for ranking or retrieval, right? And then for ranking, since you don't have to put any constraints on it, kind of, you can just use whatever architecture you want. But then a user in a two-tower retrieval setting, you can't learn interactions between the user and the item, because then you won't be able to do the retrieval. So it's kind of, you have to put a constraint on it, which typically leads to the fact that these models are not performing as well as they could be. But the big plus is that you can very efficiently then say, okay, this is my user ID. Give me the closest, or like the tracks that are like the highest probability that this user would like it. So now if you have like a system, let's say, let's take a Spotify one. We have Discover Weekly, where like the whole pool of tracks that we take into account is in the millions. And then we want to end up with like a playlist of like 25. So then we put it to the retrieval, then we like filter it down to maybe a few hundred tracks or a few thousand. And then we do have a score for like, okay, what does the model think of all these combinations? So we could already order them. But typically you don't do that, because you can actually then give it to a ranking model that is better at that ordering, and then kind of gives you better results, kind of. So you can make it easier for yourself to only have one model that does all the predictions, but typically to get the best performance, there are actually multiple models involved, which makes like deploying and building these recommender systems super complex, because you don't have to worry about one model, but there are multiple models that you need to care about.
So can you give an example? I guess retrieval-wise, we can use standard matrix factorization techniques or two-tower or factorization machines, and you get some score out. But you can potentially then use that to just retrieve the top one. But then you can add some kind of additional ranking. What is that additional ranking? How can you give an example of a model?
Yeah, so typically, like if we go for the retrieval, like a few more seconds, then like we could then export all the user vectors and all the item vectors. We can load that in an index, an approximate nearest neighbor index, and that allows us to do that super fast retrieval. So then we get a point in this vector space. So each element in this vector space has a distance to each other, and we can build a certain index that makes that retrieval super fast. So it's not 100% correct, but with like high likelihood, it gives you, if you have a point, that could be a user or item, give me back the things that are the closest to it.
And that's still in the retrieval phase.
Exactly, yes.
And it's just similar to the Spotify Annoy kind of library, right?
Yes,
so it's an approximate nearest neighbor. It really, really quickly finds something in a huge high-dimensional space, or hundreds of millions of users or whatnot. But it may be wrong. It's some kind of approximation potentially. Okay, so then,
which is another reason why you want to add that ranking stage, to make sure that there's nothing in there that is wrong. But then if you filter down, let's say you start with 1 million items, you filter it down to like a few hundreds, then all of a sudden it's fine to give that to a ranking model and give like the user features and the item features, like the combinations of all of those, get 1,000, let's say we have a filter down to 1,000, get 1,000 scores back, and then we can use that to order it. And then we have with higher likelihood, we get like the better ranking.
Is that another like neural network or something, or how?
Typically, yeah. So, and there are like special type of model, and typically there you could also use a vectorization machine. You can use, there are these models that you can do wide and deep that we started this conversation with. There are like models like DLRM deep and cross network. So DLRN comes from Facebook, which is a model that automatically learns these important feature crosses to learn these higher level feature interactions. Deep and cross network is like a similar type network that does it in a slightly different way. So those are making your life easier as a machine learning engineer because there's less things you need to worry about because the model learns more things by itself. Kind of.
So now we're down to having a set of tabular data, the features for each user and item, and then you want to make some kind of prediction on the to what? I mean, what is really the ground truth when you train this model for the ranking purpose?
So typically you could even train them on both the same task. So like you can either use explicit signals. So if you ask your users, okay, rate all the items that you interacted with from a score of 1 to 5, then you can use that as a signal. But that's typically not what's happening because users typically are not spending a lot of time to give you explicit feedback.
So just to give an example, explicit could be that you on Netflix, for example, gives it like a is it thumbs up they have there or some? It's a 5-star thing, right?
They start in 5-star. I'm not sure if they still have it. Maybe now I think they just introduced like thumbs up and double thumbs up. So now I think they have like 2 different parts. But for a while it was like between 0 and 5.
Yeah, but it requires some kind of manual action from the user to obtain this kind of explicit ratings. But then you have implicit ratings, right?
Yes, which is basically the things that a user interacts with, which you can kind of get for free as you're a platform.
So it's simply if the user viewed that movie at all, so it's 1 or 0 more or less, right?
Yes, exactly, yeah. So, and then typically you only have positive interactions. You don't have explicit negative. So then there is like a lot of, that's what we're working on now. There are different strategies you can take to guess what would be good negatives. And that actually makes a huge impact how well these models are learning. And like you make a lot of like computational trade-offs kind of.
Yeah, cool. I see the time is flying away here. And we really want to get into, the tabular kind of data with neural networks, etc., and so many other things. So I'm trying to speed it up a bit here.
Yes.
Okay, so Merlin then has a number of components. It has the different parts: retrieval, filtering, ranking, and ordering in the end.
Yes.
And the ordering then is more on the post-processing, trying to add some business logic to it.
Exactly. So maybe some extra constraint, diversity, stuff like that. Like it depends on from like use case to use case.
Yeah.
But yeah, it could be artist diversity, it could be item diversity that you want, like a certain female representation. Like there is all kinds of stuff that you can do there in order to maintain like good hygiene of the system, kind of.
Basically add bias, I guess.
Exactly, yes.
Some kind of prior that you want to add. What do you think if we just move to Spotify and the word-to-vec approach that they have chosen after a lot of iteration, experimentation?
Right.
They came up with word-to-vec, which basically not even use the user item interactions anymore. So it's just the songs in the playlist, right? And then predicting is this song from the same playlist or not, more or less. Right. What do you think about that? It seemed to work well for Spotify. Do you have any thoughts about this is a good retriever or not?
At Spotify was a really hard one to beat.
Yeah.
Like it's tricky as well if you start to add more machine learning to your platform because that changes dynamics as well. Like back in the days, most of the people, how they found music was organic, and a lot of people were creating playlists. But then when they added more machine learning, more and more people found their tracks through machine learning, which also meant that less people were making playlists. So then building up your training data becomes a little bit trickier as well. So over time, depending on like where you push your users towards, maybe the strategy becomes less good. But it's still a very good way to do candidate retrieval. But typically in like these large scale systems, you can even have multiple systems that do candidate retrieval. So like if we go from 1 million tracks to like 1,000, doesn't necessarily mean that those 1,000 can all come from the same system. You could actually query multiple models, and it could even be some rule-based things where these artists we want to give extra exposure. So there could be multiple sources leading to that filter down of 1,000, and then you pass it on to the rest part of your pipeline.
So if you were to give a recommendation, pun intended, to a startup that want to build their own recommender system, of course they should use Merlin.
Yes, no question about that.
But then they have to make a choice in the retriever. Let's say they want to sell books or something, and they have not a super huge amount of data, but at least, I don't know, tens of thousands of users and interactions for that. what would be your first recommendation for them in terms of a recommender or retrieval model to use?
I mean, like, if you don't have a lot of data yet, like you could look at things like Word2Vec and try to find these lists of books that are similar, right? Like you can mine the internet for these types of things. So you like, especially if you don't have a lot of data yet, you will have to add either external knowledge or kind of rule-based systems that can do, like similar to how Spotify got away with it with editors. You could also use like humans in the loop in order to build up like a relatively okay recommender system. You can start with just popularity based as well. So there are all kinds of like things you can do to just get it kickstarted, and then hopefully
the cold start problem. That's
exactly, and then to make sure that at some point you have enough user generated data that you can fully flip the switch in order to just learn from there.
I'm going to move very quickly now.
Yes.
What is Merlin Models?
So that is a modeling library that basically gives different options for both retrieval models and for ranking models. So we integrate with TensorFlow, which is one of the big deep learning frameworks. We're integrating with PyTorch, which is the other big deep learning framework. And then we integrate with a few sort of more specialized modeling layers, like LightFM, that's kind of factorization machines. We have Implicit, which is kind of a sort of matrix factorization library that is super optimized for GPUs, which is built by one of the team members in the Merlin team. So right now we integrate with like 4 different options. We're planning to add a few more towards it, but most of our engineering effort is actually going into integrating with these deep learning type frameworks. Because
so in short, it basically adds a framework or a connection to a set of well-established retrieval models that you can have.
Yes, and basically, since we also have a data preprocessing library, we worked a lot in integrating these as tightly as possible. So when you preprocess, and it gets a bit technical, when you preprocess your data, we allow you to give us a little bit of meta information to say, okay, these columns are user columns, these columns are item columns. Based on your transformation that you apply, we can know whether it's a continuous feature or a categorical feature. So we add all the metadata to what we call a schema, and it also has like, for a categorical feature, it has things like the cardinality. So if you have like the genres, we automatically infer how many genres are there, and we give them all like a unique ID. And we leverage that schema in our modeling library wherever we can. So then you can basically instantiate a model from a schema, and based on how you represent your data, you can basically create the model in a one-liner. Because typically in a lot of these machine learning modeling frameworks, you have to first do your transformation where you basically give a lot of information, but you can't bridge any of that information to your modeling step because it's typically a different system, it doesn't integrate. So we spend a lot of time to making the modeling as easy as possible by just knowing a little bit more about your data and then making a lot of like opinionated calls. That is kind of what is being done in the industry. So we want to give like sensible defaults. But then if you want to learn more, we allow you to override all these things, and we want to, so it's kind of like progressive. We can kind of show you more if you want to sort of tweak more. But the
helping people to choose the right model and the defaults and hyperparameters for them that you can.
Exactly, yes.
What is NV-tabular and perhaps Rapid's CUDF library?
Yes, so NV-tabular is our preprocessing library, and QDF is basically the GPU implementation of Pandas. So it's a library where you can work with data frames. So it's essentially kind of like Excel type sheets of data. So you have different columns with different properties, and we allow you to sort of use standard transformations. So you can build up a program in NV-tabular to say these columns should be transformed like this, these columns should be transformed like that, and then we execute it super efficiently all on the GPU, and then we output the schema for you automatically as well. So we infer a bunch of things as well. And then
what is most similar to API-wise? Is it more similar to NumPy or Pandas?
So QDF is completely similar to Pandas.
Yes.
NV-tabular has its own API, which looks maybe a little bit foreign as like a standard Python developer, but it basically allows you to chain operators together with like the right shift operators. So you can basically say these columns as like a list with like the different column names should be processed with this operator kind of, and then you can build up a graph in that kind of API. And now we added tagging lately, so then you don't have to say, okay, these are all the names of the columns, but you can say every column that's tagged like this should be processed like that. Because if you think about NLP, it's like natural language processing, it's all language. So there's kind of like, from a modeling perspective, you completely standardize it. Any language you throw at it, it will be able to learn from, if it is like the same language kind of. With computer vision, it's the same thing. For tabular data, that's super hard. So typically in your modeling code, there's a lot of like generic as possible, so that if another team comes along or you change something in the data, your modeling code typically still work, because you still get a schema out that looks slightly different, but it still has enough metadata to then instantiate everything correctly.
Sounds awesome. Before we move into more philosophical topics, it would be fun to hear more about your general field of interest of trying to make, I guess, deep learning work on tabular data. And it's been, deep learning traditionally, of course, works well for images, text, and audio.
Right.
But with tabular data, it's still been struggling a lot. What's your thought about that? Do you think that will continue to be the case, or do you think that in a couple of years, deep learning will also be as superior for tabular data?
It depends on your data size. So deep learning typically is hungry for data. So I think that's also why deep learning for the first time on tabular data started to outperform like more traditional algorithms like gradient boosted decision trees on recommender systems in general, because that was like the first kind of tabular use case that had massive data sets that actually then made sense to construct specialized deep neural networks for it. Yeah. So I would say if your data set is large, then I would expect that if you train the right neural network, it would start to outperform the gradient boosted decision trees. The problem is that a lot of these open source data sets are super small, or companies think that a large data set is 100,000 or 200,000 rows, which is typically not the case. Like you need much more, and the more features you have, typically also the more data you need in order for the model to learn. But hopefully over time, we can start to make deep learning more efficient as well when it comes to the data, and therefore make it more generally applicable for normal tabular data sets as well.
There have been a number of models for still working with tabular data in deep learning space. Do you have any favorites one, or the one that you think have a big future potentially?
So on the ranking, so like basically the DCN model, the Deep and Cross Network V2 from Google, and the DLRM, basically these type of networks that can learn these higher level feature interactions.
Right.
I think they have like a bright future. I also think that, especially in the recommender space, like if you can make your recommender into like a session-based type fashion, where you can get it more sequential information, so not just a user and an item, but on the user side also say these are the last 100 tracks it interacted with, and these are maybe the last 100 artists it interacted with.
During a time frame as well, I guess.
Yes, so you can make it much more contextual, and then you can start to utilize as well like these transformer architecture and all these newer.
So transformer has a place, you think, for tabular data in the future?
Yes, if you at least for sure in recommender systems, but we expect it in more places as well. So one of the first library I helped build at NVIDIA was Transformers for Rec, where basically we're integrating the Hugging Face Transformers library, but then allowing you to pass in tabular data where maybe one column is sequential. So it could be that you have one text column.
It was another one called BERT for Rec as well, right?
Yeah, so that was the first one that had success with kind of using a transformer. And then our paper showed that with our library, with newer type algorithms like XLNet and like other types we were actually outperforming the BERT for Rec.
Oh, nice.
And we also, it kind of showed that, because like if you think about like democratizing recommender systems, kind of our playbook a little bit is coming also from Hugging Face, which has is this French company is doing this for NLP, natural language processing. They had like tremendous impact on the whole industry, because they have this library where every new paper gets implemented and they share pre-trained models from this. So our goal is kind of doing that for the recommender space, but it's fundamentally a different problem, of course, because when we can't train a model for these companies because they own the data, we don't. So we kind of have to give them the architecture and the type of things they're working for that, and then they have to do it on their own, which also means that the how the data are structured and stuff could be so different from one data set to the other, so that if we do a lot of experiments on public data sets, there's no guarantee that what we found on those public data sets translate or correlate with what you have internally at your company. So that means that from an engineering perspective, our libraries have to be super composable, and you have to like change one bit for another very easily in order to then come up with the best system for your infrastructure. So we spend a lot of time on sort of adding composability to like the pre-training steps, so that like, for these transformers, like there's the type of task that you train. You have like a mass language modeling, and you have a few others. So we showed that like changing the pre-training strategy and changing the architecture from what was used in the paper could actually get a beneficial impact, because these transformers architecture are typically made for natural language processing, but now we're applying it to a domain that's completely different. So we're trying to mix and match and make that easier, so that you as a company can kind of come up with the best configuration that works for you.
Sounds awesome. And I want to start moving into more philosophical ones. So perhaps we should take a small shot as well before
Let's
we do
do
that.
it.
Goran, are you up for it as well? Happy
Cool.
Easter, right?
Happy Easter.
Thanks, great. Okay, so perhaps one of the more philosophical things and more, I guess, long-term things that NVIDIA is working with is also the Omniverse. I think we mentioned that partly in the beginning. What is that, and what's your thoughts about that? Do you think that will be a big thing?
Yes, so it's basically a digital version of real-life places, the real world, and everything is like physics informed, so it's as close as possible to the real world, which is super important for things like robotics or self-driving cars, where obtaining training data is super expensive. So the more you can simulate, that makes it much easier to generate training data that I've never seen before, and then hopefully if it's like realistic enough, then it would translate to the real world.
I mean, as we said, I think in the beginning, it's kind of a natural, really good fit for NVIDIA, since it started off as a gaming company, has awesome tools and experience in graphics and how to render and build.
Yes, I have a question. So, what is the difference between Omniverse and Metaverse and Multiverse and?
Awesome.
No, I'm serious.
No, of course. Yeah, please.
Omniverse
Mark.
is like the platform that NVIDIA built to generate these virtual worlds, and they are super useful for the metaverse, which is this like general term for like us living in virtual worlds essentially. So it's like one system that helps you generate these things very easily with like designers, but also adding enough flexibility to make sure that certain objects behave. So you can put an AI algorithm how a certain object moves in that world. So you get a lot of complexity.
It's a tooling to add or create your own like metaverse in some way. Is that a good way to phrase it, or?
Yeah, so there are like many different use cases. So like the biggest use case now is, for instance, like Amazon warehouses. They can completely get a virtual replica of their warehouse, which means that if they make like a scheduling decision, or like what changes if we change the color of certain of our boxes, then they can first do this. Like they can simulate and they can kind of see what happens, and then based on that they can make educated decisions around, okay, maybe this is what we have to do in the real world.
What is a metaverse, by the way? Perhaps we should try to go back and try to define that in some way.
I think my definition would be like us living in a virtual world, so building a virtual world that behaves like our real world. So it feels like it's the next computing platform, or like it could be like if we have VR goggles or like AR, that like if it's more and more us living in like a virtual world. So Facebook is pushing this narrative, or like Meta, I should say, they actually changed their name because of the metaverse, that they want people to get an Oculus, so one of these VR goggles, and then start taking meetings in this virtual world with their people to get like a sense that you're closer to each other, even though you're all working remotely. That's just one of the use cases, and there are many others.
Would you argue like even like simple games potentially is a metaverse? Like Grand Theft Auto is a metaverse in itself. Is that a fair way to describe it?
Potentially, yeah, I think so. I mean, like with some, okay, I'm going to sound old again, but some of the kids that are growing up now, like they have a lot of social interaction in these virtual worlds, and that could for sure be Grand Theft Auto or like whatever game they're playing. So I think if it has impact on your real life and you have social interactions there, and it makes you feel that it's sort of it's closer to reality, kind of. To me, it would have like some sort of social element that you're somehow interacting with people, with real things.
Does that have a connection to the real world, or could like Minecraft as well be seen as like a isolated metaverse?
I would say so, yeah, because you still have connections with real people. Yeah, like the people that are in there are real, but like the world is completely different to ours.
So if it's just AI people in there, is this not a metaverse anymore?
That's a good question. I would still say it is, because as a human, you would still perceive it as maybe they're real.
Feels like it's human there.
Exactly.
Yeah. That's good.
I think we should have like a episode on this by itself. Yeah. But this is coming actually. Yesterday came where Meta plans to take a nearly 50% cut on every virtual asset sold in their metaverse.
Which absurd.
But absurd. I mean, that was the plan from the beginning, right? Which is a little bit hypocritical, because they were complaining quite a lot that Apple was taking 30%. So yes. Here it goes with your 50, right?
Yeah, I think the game has started, but there's a lot of like interest from like the Web3 community, so the crypto space, to do these kind of things as well. I think part of this metaverse type of element, like it's the social interaction, but it's also economic value. So you have elements like a house in this virtual reality, or like a certain object that you can sell for real money. Like there's value in it. So you could be like a millionaire in kind of fake, whatever you would call it, in this world. Yeah. That would potentially also transfer to the real world, as long as soon as you can sell it to someone else that is interested in it.
Cool, but Omniverse also have more, like not only for entertainment purposes, right? So you can have like digital twins in some way. Yes.
Yeah, I think right now they're mostly focusing on the business use cases, but there's no one, like everyone can use this tool to kind of do more consumer-facing things as well. Like I think NVIDIA tries to be more like a platform, like play here, where they want to give people the tools to turn it into something useful. And then one of these tools could be companies that are using it to simulate things. Another thing could be that someone builds a game like World of Warcraft through this that is like closer to reality.
And for more commercial purposes, it could be like to, as you said, simulate a warehouse or a self-driving car or some kind of manufacturing plant or whatever.
And it also like they showed demos from like individual designers that could like design realistic looking things way easier on their own. But right now, for instance, if you want to like drop a ball, and sort of like there needs to be a whole team sort of ensuring that looks realistic with like the light that comes off, like how it falls. And right now they have this like language, I don't know exactly how it's called, but basically you describe what needs to happen in that scene. And then since it's physics informed, they can kind of generate it for you looking realistically. So they showed, like I think they give this tool like a few demos ago to a bunch of designers, and the stuff that they could come up with on their own was really impressive. And then if you would see how much, for instance, Pixar needs to spend on these things to make it look realistic. So in that sense, it could also be just an animation that you make of it. It doesn't need to be like a virtual world. Like you can basically, like the possibilities are endless.
But Omniverse then, is it fair to say it's similar to what Merlin is a set of libraries for recommender systems? Yes. Omniverse is a set of, or a platform for building metaverses.
Exactly. Yes, that's how you can see it. And then they have like a self-driving car division as well. That's basically, and it's all using the same hardware to build these things, but then focus on a specific vertical. So self-driving cars is one. They have genomics. They have like healthcare.
Didn't they have one for like climate change, trying to simulate the whole world or something? What was that called?
Yes, I think they're still doing it. They're getting like further and further. So there they also have like physics-informed neural networks that they're trying to simulate what's going to happen in the weather. And they're kind of been showing recently that they need to have a few more orders of magnitude larger like size compute in order to do this realistically. But for like constrained instances, they could show that they're much better now at it. So for the first time, they could be better at it at humans. So there's a lot happening there as well.
It's nice to hear that NVIDIA has computational problems and not having their computational needs met.
No, definitely not. We need a few more orders of magnitude higher in order to keep pushing. And if we compare these deep, like largest neural networks to the amount of like neurons that you have in your brain, we're also quite a few orders of magnitude behind, of course.
But what's the right way to view it? This kind of Earth 2, whatever it was called, is it correct to say that by having a digital twin of the Earth in some way,
that's one of the ultimate goals, actually.
Yeah, and then trying to, I guess, simulate with different changes that we have in the world, see how that impacts climate change in a faster pace, basically, and in that way try to experiment with
Yes.
ways to fight climate change, right?
Exactly. But the digital twin of the Earth, like there's many more different use cases as well. So they're trying to now have one that's just all the roads in all the. So they're trying to focus on the roads for self-driving cars in like the US, I think Europe and Asia.
Yeah.
And then I think they started like a sort of focused effort. I don't know exactly, but then at some point, like if you have enough self-driving cars driving, so they have like this deal with Mercedes and a few others. Then at some point you can do the same as Tesla is doing, where you have so many sensors on the road that at some point you just keep updating in real time the different roads of the world. And with that you can do all kinds of stuff as well, of course. So it's like looking at it from different angles.
I mean, I think it's really awesome to see how we can start to use all the amazing computational power that NVIDIA provides for something really good and important for our society.
Yes, and they try to do a lot of like genomics as well, and like COVID research. Like there's a lot like of progress recently happening in drug discovery as well, which is partly interesting because it's kind of a matching problem. So a lot of the algorithms we're using for recommender systems are also using apparently in drug discovery, which is interesting. So we haven't really started looking at that as being Merlin, but we've seen some libraries that they're using, and there's a lot of similarities. So that might be like a use case that we'll look at afterwards as well.
One very common topic that we speak about in this pod is about the power of the tech giants, and I would argue that NVIDIA is one of the tech giants as well.
Yes.
They recently surpassed Meta, right, in valuation?
Yes, at least for a brief moment in time. I'm not sure how it is now because the stock went down a bit afterwards.
Yeah, Meta went down kind of
it's
strongly.
Very volatile. But yeah, for a while in market cap, they were higher. Maybe they're still higher, I don't know. But yeah, it's in like the, let's say, 400 to 600 billion range. So it's a lot. I do think that the power of these big platforms is an issue. I think at this moment in time, I don't think NVIDIA is there yet that it's starting to abuse its power, but they've definitely, like they're with the largest tech companies in the world that are still like a few times bigger than NVIDIA is. Like I think Microsoft is like 2 trillion now or something, 2.5. Apple is something similar. That is challenging. And I think AI will have a big factor in that as well. And that is something I do worry about it a little bit.
So what do you worry about? I mean, for one, what we have said before is the tech giants have found a way to use data and AI in a way to scale up their business and automate a lot of their processes, and it works really well for them, and in that way they can scale up their business and the monetary gains that they can have. And a lot of other companies try to follow, but it's really hard, and you don't have all the research groups and knowledge that these kind of big tech giants have. And NVIDIA, with all they do a lot of research as well, right?
Yes.
They really amazing
I think
things.
the AI community in a way is good because they do a lot of like public research, and there's like a strong culture around publishing everything.
Yeah.
So I think it's much better than maybe like pessimists would think it is, because there's much more sharing going on between these big companies. But there's definitely like a big computational budget aspect that is starting to get tricky. Like the larger these models are becoming, like a fewer amount of companies are able to pull it off, right? Like it's not only just paying for the compute, but it's also the actual experience of
how to do it, right?
How to do it and how would you experiment with it. It's not just, okay, I spent $2 million to train like GTP or like GTP 3 or 4 or whatever it is, but it's also experiment and getting more, like if you need to train engineers to get more used to how these large models are working, you will have to give them iteration cycles. So that means that will cost a lot.
Yeah. But how do you, I mean, for one, it would be weird, I think, to blame NVIDIA for the success they have had. I mean, they have simply become the most dominant player in the AI hardware space for a good reason, which is simply that they provide awesome products. But it also is potentially a problem from a monopoly point of view if you don't have a working market with competitors. Do you have any thoughts about that? We also have a licensing structure that they have with consumer grade versus if you have data clusters that you put your cards in, etc. I mean, they can more or less choose their terms because you're so dependent on NVIDIA these days. What do you think about that? Let's imagine that you were Jensen Howe now, and you have a way to say, okay, I can 10x this company because I have an awesome idea, and if we do this, it will 10x the company valuation in 5 years. But that will mean that we will dominate the world even more. Would you do it? How should you do it?
Maybe I speak over it, but it still feels like NVIDIA is the underdog here. It feels like an Apple or Facebook or Meta now and Google and Amazon are much larger. They all have their public clouds, which just make an insane amount of money. Yeah. So I think it's expected that they will start to move more and more towards building their own hardware as well, which is potentially a threat.
So you are starting to see a lot of competitions here.
Yes, there are more and more companies that start to run their own hardware as well. And I think that is in a way it's good because there's more competition needed. What I worry about a little bit is like it's already I think the highest estimates are right now that I think 40% of all the money that VCs invest in startup flows back to Google and Facebook and Amazon in terms of like advertising that it's kind of a tax, right? Yeah. Like you don't even have a choice. If you want to grow, then you need to spend these money on ads and also on public cloud. So there are more and more companies like Spotify as well. They're just completely relying on GCP. So there's so much money like flowing back on Apple is just of course the App Store. I think if the next frontier is like the metaverse, what you just showed is scary, that if they really think that they can pull it off 50%. I think Apple at some point tried to release Apple News, and they also were thinking about a 30-40% take or something. So I think that is clearly monopolistic behavior. I haven't seen that yet from NVIDIA. Maybe it's there, but I work on this tiny little, it feels like a little startup in this massive company, and I joined within COVID, so I have very little inside information, but happy to speculate. But especially if these large language models keep growing, I think it's a tricky point for companies like Spotify as well. Like they have more and more interest towards it because they're doing podcasts, which is language. Yeah. But what are they going to do? Are they going to treat it like cloud? And are they going to just outsource it to Google and just spend even more money on them? Or are they going to try to do it in-house, which potentially is like a huge investment with unclear how much that will pay off. And I think more and more of these companies will have to make these decisions, which even more reinforces it very heavy monopolistic environment that we're in. And I think the metaverse is one, in all these potential new computing platforms, it's always the few companies that are trying to get there first and trying to become the platform and then basically imposing a tax on anyone else. And I think it's very hard for startups to compete with that. And I think, also in Europe, we have very little success in that. So I think that is very tricky.
Right? I mean, it's not a single cloud provider, at least to the scale of American and Chinese ones.
Exactly.
Isn't that strange?
And these are consumer-facing internet companies. It's kind of like Spotify and maybe a few financial services that's in fintech. We have a few, but it's not much. Yeah. And I think that is worrying, and I think that they're trying to change that, but I think it's tricky.
Yes. Yeah, that's hard. It's a bit of a problem when companies are too successful, but you shouldn't really blame the company for that. They're simply doing awesome stuff.
But the government can take action here. For some of these places, it feels like regulation would help. Yeah. But it would be interesting to see how that plays out as well. GDPR was, I think, a good idea. So there's kind of the privacy regulation where kind of Europe led the way. I think in a way it also led to even harder to compete with these big tech companies because for them it's much easier to comply. So it's also there's all these second order effects towards this. I think that puts Europe in a tough spot. But at least they're not getting a lot of tax money from these large tech companies. So they are incentivized to at some point maybe change something. I think the US is not going to do it. So maybe Europe is going to lead the way there. But it feels either we're going to be in a world where it's going to be way more privacy aware and more of the data stays on the device, and maybe Europe will ensure that with some of the regulations. But kind of the world
but it could turn out, because I agree completely with what you said, and it's something we've said as well a number of times, that GDPR has awesome intentions.
Yes.
But then
the devil is in the details, and it's
the implementation of it turned out that it's super hard for smaller or mid-sized companies to compete because they don't have the legal resources to know how to comply with it. But it's not a problem for the big tech giants. So in reality, it actually increased the AI divide potentially, or the divide to the big tech giants.
And I think it's interesting as well what's going to happen with this whole Web3 crypto movement that is kind of...
What do you think about blockchain? Okay, since you opened that can of worms as well, what do you think about blockchains in general and their importance to...
I started to look at it
3.0.
more seriously just because the amount of engineering resources that is going into it, and like a lot of people I respect that. So it's not just grifters, like it's a lot of really impressive tech that it goes into it. So there might be like a bright future there, but it all falls or stands with regulation, and I think it's very unclear what's going to happen with that regulation. I do think potentially having like a decentralized social network where basically people can choose what algorithm to use and have different companies that can have their own timeline. As like a Rex's engineers, that could excite me. I think that could give people more control. That could sort of, people can be in control if they want to be in a platform that is sort of pushing free speech or is more heavily policing. And I think
Is
that would
is
help.
that a good way to say it? Because I have a bit of I'm disappointed simply at the current implementation of blockchains. I mean, if you think about the current, the intentions are great. I mean, you want to remove the middleman, and it works for currency rather well, and you can remove the dependencies to banks, etc., and have some kind of democratized or more decentralized kind of implementation of things. So the idea is great, but then in reality, if you try to find one really successful non-currency based blockchain technology, it is very few, I would argue. Can you think of one big successful blockchain product these days?
Not yet, outside of like currencies. I do think there's a lot of potential in like the metaverse type place. I do think there's a lot of potential in like the gaming space where like there's a lot of people that spend 7 hours a day in these games, and like if they have
and actually that if you think someone suggested for example that we could have a regulation saying you should have the option to choose what kind of news feed recommender system you should have in Facebook or Instagram or Twitter or whatnot.
Right.
And that could potentially, I'm not sure if I see the blockchain connection here, but anyway, that could be some way to try to have a bit more ownership as a user in how these big tech giants are working.
Yeah, I think that is very promising to me. I'm not sure if we can get there, especially because that's also why I brought it up, because it's completely sort of against what Europe is trying to do with GDPR and like the right to be forgotten. Like if that data is all on the blockchain, like how can you make sure that like your data is deleted? Yeah. So pulling that up from an engineer perspective, I think is very tricky, and I'm not completely convinced that the blockchain is the right way to do it, but just having one provider that has the data and multiple sort of platforms can talk to that as a front end, I think that is very exciting. I think that should be where we should be heading, because I think people need more control. And I mean, now, like today, that Elon Musk tried to take Twitter private and for 100%.
He did actually make an offer, right?
Yes,
for the
he
whole
made an
Twitter.
offer, exactly, yeah. So he wants to have 100% and take it private with the arguments of free speech.
Yeah.
And I think that's valid. That's capitalism at work. But I think there is also, like, we don't really know what will happen if it's only free speech. Like, I think what happens with bullying, like, there's a lot of, like, things that is sort of unclear what would happen. And in a way, it seems like people feel very strongly on either side, right? On the free speech side or on kind of the policing and sort of like making sure that people are not getting fake news and all of that.
Propaganda that's happening.
Exactly, yes. So it seems like the only possible solution is to then take the data out, have multiple front ends, and then let people choose. Like if you want to go in the Wild West, be my guest. But if you want to be like a more police version, it's out there as well. Because right now, it's just like, Elon Musk is very wealthy, has this opportunity to take it to the free speech side. Before they were it was more on the policing side. So it feels like, then it's all of a sudden like people with money deciding, which also doesn't seem like the best possible solution.
You think there is such a thing as a good dictator? Like,
ideally, yes, but I think in the end, it's like there are so many sort of second order effects that's like we have to live through as a society. Like social media only have been here for like, what would it be, like 4 or 5 years? So like not even 10,000 days maybe. So like on like the whole society, it's
Facebook came online like 2005 or something, right? Or
yes, but I mean more like an entire generation growing up with it and having like severe effects. I think when we started with Facebook, like it didn't affect us much. Like it was like fun to be on it. At some point, the moms and the dads took it over, and then people moved to Instagram and something else. But I think now there is an entire generation that completely grew up with Instagram, and like there's a lot of effects on these kids that we can only know when just living through it, kind of. And I think so. It's in my mind, way too early to make strong calls on whether we should be completely on the free speech side or something else. We have to experiment. But right now, it's like the environment that we're in, we can't run enough experiments in order to figure it out, I think. So the scientist in me is not happy with like how many sort of iterations we get, because I think we can't just pause the world and think about the best solution. Like, I think that doesn't work. Like, we need to run experiments, we need to figure out what happens, we need to philosophize about what happens.
Perhaps we should have a digital twin of Twitter or something.
That would happen, yeah. It would be hard to pull off though, but like something like that where you can simulate these things, I think is the only way to actually get to a better solution. Because I think right now, people feel very strongly on each side, but I feel like there's not enough data in order to make justified calls on either side.
Awesome. As perhaps one of the last questions, potentially, before the after work. So, AI is growing very rapidly in terms of power, and of course we still today have a lot of very narrow AI tasks that are superhuman in terms of, playing chess or perhaps driving cars at points soon, etc. And then it is growing increasingly general, with models like GPT-3 and these kind of large language models, and going multimodal and multitask now with thousands and if not millions of tasks with this big, Google Pathways system. Palm, yeah, exactly. So we can very easily, I would say, see the trend where it's moving. It's moving to these kind of large models. They are getting increasingly multitask and increasingly general. Are you concerned with that? What do you think will happen in like 5-10 years? Do you see a point where potentially we will have like some kind of singularity where AI systems will surpass humans in most tasks?
I think we're pretty far away from it. I don't expect it in my lifetime, but who knows? Like I try to keep like an open mind, but I think there is too much stuff that we still have to do. I think it's also with these really large language models, it's really hard to figure out where we are in the life cycle, because I think we don't understand the complexity of the brain too much, so we don't understand the end goal that much, but we also don't understand too much about the internal workings of these really large neural networks. Like there's only maybe in the order of tens of thousands of people at max right now that have the capacity to really tinker with these models. And because in a way it becomes like a natural science, right? There will be people studying these large language models and trying to understand patterns and trying to find new things. So in a way it's moving computer science and machine learning more to like a typical science like psychology, which I think is interesting.
Perhaps it's moving from natural to artificial science.
Exactly, exactly. But we need more people that are classically trained in order to do these things, in order to tinker with this, kind of like a black box, and trying to understand more in the form of experiments. And I think we're just starting with that.
If Jensen is correct, that we are going to see, we have already seen like a million X in terms of the performance that we can solve tasks with in terms of speed or time or memory or whatnot. And he says that will continue for coming years. If we continue to do a million X in coming years, and that basically means a very strongly exponential increase in our abilities to solve different problems, and how intelligent in some way the system will be, could potentially go really quickly, right?
Yes, but I agree here with like Jan LeCun, which is saying that there's only so much you can do with supervised machine learning. And now like the really big advantage of these large language models is that there are a vast amount of text out there, and we can do self-supervised learning. So we can try to predict the next word, and by getting really good at that, you learn a lot of structure about the real world. But it still needs an insane amount of data in order to do so, and not everything in the world is described in natural language. So there is still, I think in order to really get there, there's still quite a lot of improvements we need to do from the algorithmic side of things. I think we need to do something similar for video, where you can try to predict with some uncertainty bounds, like what is going to happen in the next frame of a video. And right now, that space is just way too big. And I think, so that's one, you need to do it on video. And then I think the second step is you need to interact with the data, with the world. You need to, in order to make an action, see what happens, and then learn from that. And I think if we start to do all of those things, then we'll get there, and compute is a massive factor. But I'm not on the belief that just with language alone you can get there. But I could be surprised. Like, they got way further with just language than I ever thought they would be. And it seems like these models have a pretty solid understanding of the world. So maybe you can push it a few more like orders of magnitude further. But I think even with the language models we have today, like, they're way more powerful potentially than we might think.
I think that's a good conclusion to say, because I think a lot of people agree that just language by itself and this kind of very simplistic objective of predicting the next word seems to produce surprisingly powerful models, if we call it that.
Yes.
And that's, I guess, cool. I mean, a simple technique like this just increases scale and suddenly seems to do a lot of cool stuff is impressive.
Yes.
Probably not perhaps the best way to do it, but still it works surprisingly good. Right. If we do it a bit more simple, and a way that if we just think like 5 years ahead or something, one way that I usually try to phrase it is that I would argue that AI are good at some tasks, humans are good at other tasks. AI, for example, can be good at going through a huge amount of videos or thousands of pages of text and can do that quickly, but it does it rather superficially. Whereas humans, they can't efficiently go through a huge amount of data, like for recommender systems or whatnot, to find the proper score. But it can look through a small set of data points and do a much deeper kind of analysis of that than an AI of today can. So then I would argue that I think we should rather develop the AI towards what the humans are bad at and have a nice complement of the two. So we use AI for what that is good for and humans for what they are good at, and try to develop the research in that direction. And then we can find the best use of AI and humans together.
Right.
Would you agree with that?
Yeah, I completely agree with that. And I mean, like, what these language models are seeing, supposedly are pulling off. I've never been able to play with it myself too much, but I've seen the demos. It's super impressive. And I think even if the AI in the next 5 years doesn't scale up a few orders of magnitudes anymore, we just are stable, even then I think there is an insane amount of opportunities just with the algorithms we have today. And I do think it will grow further. But I do think there is a lot of potential second order effects that will be very interesting to see, where what's happening to search. Will it just be a giant neural network that will do all of it? And then if so, what is going to happen with search optimization? Are there going to be companies that are trying to sort of have these poisoning attacks? They are sort of trying to maximize the log likelihood that something still looks like one class, but it is something else. That part I'm a bit worried about. And also maybe the computer security kind of aspect on it. It's any rule-based systems or operating system and all of that. There is this whole secondary market of 0 days where there are people that found vulnerabilities in these systems that are secretly selling to governments so they can be hacking in this. What would be the 0 day equivalent on these large language models? We don't really know. And there's an incentive for the people that find it to not give it out. That is a bit wild word.
And even to speak about using AI for warfare or for propaganda purposes and so many things that of course it can be abused and is being abused to a large extent already today.
But I am an optimist, so I do think in general it's a good thing, and I think it's also unpreventable for humans. We're going to head to that direction anyways. All the incentives are lining up. And I do think in the end there will be a thing that's used for more good than it is for more harm. But more power comes more.
I think NVIDIA is doing a lot of great work to move in that direction, especially with the climate change kind of project, etc., and awesome recommender systems as well that we are having. I guess we're basically living in very interesting times. Coming 5 years, I think so many things will happen that will be very exciting to see.
I'm very happy to live through this time, especially with the background that we have in machine learning. I think it's extremely interesting to see what happens.
Mark, what's happening next in your life, coming months, personally, professionally, something special coming up?
I guess we're going to stick around in Stockholm for a bit longer. We just bought an apartment, which is nice, so I moved in there with my girlfriend. Before that, I moved here again, in May when I joined NVIDIA. So she was living in Paris, I was living in London, so we're living here now, which is fun. I think we've done a lot of the groundwork with Merlin, so I hope next year we'll be more actually seeing how customers are using it and actually getting real life usage of it. Because at time it really felt like playing a game because I was building a software that was not really used yet with people that I've never met that are spread out all around the world, which has been challenging at times. So I'm very looking forward to making it more real by meeting these people that I work with every day, making the product into a reality in terms of like actually getting real usage of it. So I'm excited to see if like the sort of the seeds that we planted and we've been working very hard to grow a little bit, if it actually turns into like something that has like real world usage, because you never really know that if you start, of course.
Start meeting people in post-corona times, hopefully sometime soon, right?
Yes. I mean, the first step is being on this podcast talking about tech for 2 hours. Like I only knew that virtually now, so it's nice to actually see a real face. So it's I think it's going to feel much nicer now as well, of course, having lived through it and now like properly seeing how nice it can be to like meet people and sort of have those social aspects that maybe always you took as a given. So I'm excited about what will happen in the next year.
Awesome. Anyone that you would recommend to come to this podcast, someone that you would like to listen to, that we should invite potentially?
I mean, here in Stockholm, I would say Oscar Stahl, like the lead. He used to be a lead of the personalization mission. From what I heard, he just stepped down. But I think he's one of the people that's like on the top of actually trying to use machine learning, especially recommender systems at huge scale, and sort of build an organization behind it and sort of try to lead that in a good way. So I would be very curious to hear that. I'm not sure how much is under an NDA and like how free he can talk, but
I know him rather well, and it's I think he can speak. He knows what to say and not to say.
Exactly. I think he has enough practice with that. So
Great suggestion. Cool, Mark. Thank you very much for coming. And we had so many topics we didn't cover, as usual, I guess. But in this case, I did really want to cover a lot more topics. And it was awesome to actually be a bit techy for once. Perhaps a bit, Goran, I think that we went too technical. But for me, it's nice to go in that direction sometimes as well.
It was fun. No, I enjoyed it.
Awesome. Thank you very much, Mark. Let's do an after work.
Yes, thanks for having me. Excited.